हेलो दोस्तों, क्या हाल चाल. So today we are going to build a multi-starter agentic app. So in which we will be building multi-model system, multi-agent system, and there will be tools that we are going to use like Langchain, Langgraph, obviously Python and Pydantic models and Python other tools. And also we will be using Redis for state management, like conversation context for the AI. And there will be Elasticsearch where we will be ingesting our specific data for our application, and based on that data we will tell different models to do different things. So there are lots of things I am not going to cover in this introduction, so I will like you to show the demo, like how the app looks right now. So as you can see on the screen, this is basically the project we are going to build, in which you can see our backend services online. So all those status basically what we are going to use, and what is the provider you are using. So for now, as I know, like we all of us, like we are a student or we are working professional, we don't have GPUs. Okay, so we cannot pull the models directly into our system, because that one model takes 8 GB of RAM or 16 GB of RAM. So we are using basically inference API from Hugging Face directly. So whatever is the free models, or with the free some limit request, we can develop the project. Okay, and even though if you want to change the provider, you can change to any other models. Let's say so basically what I have done, I have two MacBooks. In one MacBook at home, I have fully pulled the model from Olama, and I am serving this model on the my Wi-Fi IP, and in the another MacBook I am using that running model. So basically you can see I am using one of my MacBook as a VM virtual machine. So all the operation is going on that model. Okay, and the other MacBook is used for the backend services. So that is one of the thing that if you don't want to use basically any API, you can try with that approach. That is very simple. If you can do chat GPT, you will get all the commands how you can do that. But that is another part. So let's see. Here is a basic registration. So it is not needed, but yeah, I have added, so don't worry about that. So here you can see all the things on the project. You can see over here the activity, the response from the AI, the output, and the health, and the basically status of your services, they are online or not. So okay, and here is your data where we are going to insert some data for the testing. So why we are ingesting the data? Because we want our specific application queries that AI will handle. Okay, as we know, AI is already capable, AI is already know lots of stuff, because that is a model that is fine-tuned and trained on the data basically. Okay, but for our application, for our project, let's say you are working in a company or you are building your product, there will be data that AI doesn't know. Okay, so that's why we need to ingest data in and right now we are ingesting this data in Elasticsearch. So let's click, and you can see small I have added a documentation on Langfuse and Langchain and Redis for example. Okay, you can ingest any kind of data. When we are developing the app, I will let you know. Okay, not app, basically it's a backend service, Agentic AI service. So then I will let you know. So you can see data is ingested, and now we can ask like, hey, okay, so these kind of stuff, you can see all the operations, all the logs will be there. There is a conversational ID is generated, so this ID is used for your context management. So the AI will assist you based on your previous conversation. Okay, so there are some already queries I have added, so I don't need to write. And you can see this will basically search in our Elasticsearch, then it will send to the API. Okay, so you can see we got the response from the AI, that is this is the basically with the score he has responded. Okay, and you can ask other things as well, but you can see the project is not so fancy, like not so fancy in the sense we are not solving any kind of problem over here, but as I have earlier told you, this project is for your learning. Okay, learning in the sense how exactly we are using the AI to tell him, like, hey, take this data and do what the query user is saying. Okay, and there are other steps also. So all these things we are going to learn, and let me show you how it will look. So you can see this is the container we are going to use. This is a Redis container. Okay, so all the queries, and we are going to use Elasticsearch, and this is Redis container up and running, and all the logs will be there. There is a front end project, there will be agents, so multi agents like search agent, summary agent, supervisor agent will be orchestrating to and routing. Okay, so these are stuffs there we are going to build. There are routers, services, caching. Okay, there are state management utils. So these are the stuffs we are going to build in this project. Apart from that, there is a Langfuse integration also. So if we can reload and see our latest query that just I have done now, so you can see how does Langgraph work. So you can see basically there are nodes and edges in the AI ecosystem. I will explain you everything in this architectural and the introduction of AI stuff. Okay, so basically there is a supervisor agent that decide and route to summary agent, then search agent. Okay, so search agent basically goes to Elasticsearch, pull out the data, then it will send to summarizer agent, and summarizer agent basically get the data and call the Hugging Face model with that data to decide and give us a summary. Okay, so that kind of stuff that is there. So you can see all the token management and all the analytics about how your AI is using, and you can see the nodes and your edges, like how they are communicating with each other, what are the arguments that are getting passed, and what is the response of the AI. So all this stuff you can manage in the Langfuse. So yeah, this is we are going to build, and this is lots of fun we are going to learn. And while building the project, I will also keep you engaging, and you will keep on learning other things what I know about AI, what I have not covered right now. So there will be lots of things you are going to learn in this project. Okay, so let's understand architecture, and after that we'll start building the project with some theoretical part. In between the project I will teach you and explain you. Okay, so let's go. Here is the architecture, and architecture is quite simple. Okay, so it is just a high level overview of what we are going to build. So basically there will be a front-end Next.js project that will be communicating through HTTPS calls, and JWT token we will be using for protected that you have seen in the demo. Okay, protected API calls, and this is a API gateway layer, basically the FastAPI backend what we are going to build. So there will be middlewares. Okay, so in the middleware course policy, secured rate limit for the API calls and logging, and there will be Langfuse for tracking we will be implementing, and there will be 4 routers, health API, then authentication, register login, and chat basically. And after that there is one more API for ingesting the CSV data. Okay, so in the CSV data you can put anything, any data, whatever you want to ingest. And there will be service layer. So this basically called auth service layer, and this is token service layer, and this will be LLM service. So this LLM and this search service is the main what we are focusing on this project. And this project you can see as a to-do app. So if you remember, when we have started learning React Native, we directly not started with a very big project. We started with a to-do application, then we moved to another, step by step we gradually progress on our learning. So this project is also kind of a to-do project for AI learning. And once we are done with this, and once you understand how models work, what are nodes, edges, everything, then after this video, in the upcoming and next upcoming projects, we will do lots of other things with the AI, lots of other advanced things like RAG or MCP agents communication. So these kind of thing we will be implementing. But before directly jumping onto that, I want you to learn these basics. Okay, so there will be storage layer for Redis and Elasticsearch, and as I have already explained you what these two will be used for. So Redis is used for basically the storing all our data, conversation context, and Elasticsearch basically the application related data that will be fetched and sent to the LLM for processing, and then after that it will give us answer. Okay, so this LLM service will be kind of a huge, and there will be 3 agents basically. So 3 agents will be like supervisor, summary, and search. So supervisor will decide based on the query which agent we need to send the call. Okay, so if there is something you are asking for search, then it will go to the search agent, and if you are asking for any kind of summary, then it will go to the summary agent. And if you are asking summary directly, but even though supervisor don't have context about what what data I need to summarize, so it will first make a call to search, then search will return us some data, and supervisor then again send those data to summary. Okay, summary agent. So this is how you will be maintaining the orchestration layer. So this is so far on the LLM service, and yeah, these are providers you can use, Hugging Face or Llama, and for monitoring and tracing of LLMs calls and token management, etc., we will be using Langchain. And there is one important part also. As a beginner AI developer, we need to understand what is work orchestration layer. So basically this orchestration means you have know what is the meaning of orchestra. So where a person is basically guiding all the musician, like which songs to play or which music they have to produce. Okay, so basically sync multiple musicians and create one single music. Okay, so that is what happens in orchestra. So the same work orchestration layer means over here, like how our agents or basically the super agents will orchestrate other agents to work together and give us a output. Okay, so first of all, if you enter any kind of prompt, it will understand what you want to ask. Okay, and what is your context. So this will go under part query understanding, and then if there is some needs to transform your query based on the natural language processing. So let's say if you misspelled something, or if you have a previous context, like earlier you have asked about Langfuse, like how does Langfuse work, and in the next query you have asked like tell me benefits about that. So you have asked just a prompt, tell me benefits about that. Okay, then your query will be transformed based on the previous context, that tell me benefits of Langfuse. Okay, like that. So this is a part of query transformation. And if there is some kind of data retrieval, let's say we have ingested data in our Elasticsearch, so it will pull out all the data from Elasticsearch, and then it will be processed by the LLM or the model, whatever we are using. Okay, and model will produce us some answers. So every response of the AI based on a score. Okay, so whatever is the higher score, that will be some kind of a relevant answer. Okay, so that will be gone on the answer generation. And if we talk about what are the components will involve this orchestration, so there will be query processor, there is a router, context builder, what we will be doing in the first and two, and the prompt builder. If so, prompt builder is basically we will be defining agents. Okay, like you are search agent or you are summary agent, your task is to do these things, so that is basically the prompt builder. And the response formatter is like how like finally we want to send the response to the user. Okay, and data flow will be simple user query then we will be processing the query if there is any kind of retrieval of documents, so that will be happening, and then LLM will with the context of the query it will do the prompting, and then we will get the final answer. Okay, so these are basically the basic orchestration thing we are implementing, and as I have earlier told you, we are building just a to-do application of AI project. Okay, so you can see on this part we can implement a RAG or vector DB, but right now I don't want to complicate, as this will be your first AI learning. So in this I'll be teaching lots of things while building the project. Okay, so like I will be teaching you some Python syntax as well while building the project. Okay, not separate part, like one by one teaching you what is Langchain. Okay, while building the project I will explain you Langchain, this is how it works, this is how there are method, this is how we are importing things all. Okay, so these things you will gonna learn, and once we are done with that, in the next video I don't need to then again explain those things. So in the next video we will be learning more other stuffs and more advanced things. So I think this is the time now. Let's start our journey, and I think you can turn on your laptop. Okay, lots of theory has been done, and while building the project I will explain you all the things. In between I will explain you theories as well that you need to know. Okay, so let's go, let's start building the project, and you can also practice with me. Let's go. So there are some tools you need to first download Python okay, so this project we will be building for any kind of OS you are using. So if you are on Windows, Mac OS or Linux, you can easily continue with me. And right now latest version is 3.14.6, so we will download this. Okay, so these are basic stuffs like how to install Python in your PC, so I hope you can do that. Okay, so one more thing we need Podman desktop. So here you can download Podman. So Podman desktop is basically same like Docker desktop or Rancher desktop. Okay, so you can use Docker as well, but I prefer Podman right now, so you can use Podman. And there is Node.js also. So Node.js is basically for the Next.js project that we are going to use. Okay, so these three things you need to have in your system. So other two, Python and Node, you can easily install. For Podman desktop, let me install in front of you. So it will be installed something like this, and after that you can launch once it is installed. So it will be verified, then open. Okay, so Podman basically needs a isolation machine by default. So I think I have already installed earlier, so it is not showing me that the initial flow of the application. So where it asks you to install lots of other things, Podman machine, etc. So you need to install all those stuff. Okay, and after that you can see below your Podman machine default is running, and you can check with the command as well, like Podman ps. So you can see the container running or Podman machine. So you can run podman machine info. So you can see your machine is running, or if you want to start your or stop your machine, you can run these commands. So sometimes it automatically stop when you restart your computer. Okay, so you need to before running any container, you need to restart the machine again. Okay, so this is basically virtual machine where your where basically our Redis and Elasticsearch container will be running. So once this is running, Node.js is also installed. One more thing we need from the external side, that is Hugging Face API. So go to huggingface.co, create your account, log in those basic things, and after that over here go to settings. In the settings you will find one section access token. Okay, so mera password what so here we will be logging. Okay, so you can create your account, then log in and go to settings, access tokens. Okay, and here you can create a new token, so click on create new token, and here what you need to do, give its name like my token, and select all these checks. Okay, basically like make calls to your inference endpoints or repositories we don't need. Okay, access collections, billing, jobs, notifications. So other stuff we don't need, just that inference you need, and after that create token. So once it is created, just copy and save it somewhere. Okay, so these are the stuffs that we needed. And now I would like to explain you what is this models over here. Okay, so you can see there are lots of models that people basically upload on Hugging Face and register. So here we are basically want to use text generation, or if you want to do any other stuffs, you can select image to text, any to any, or okay, so these kind of stuff. And you can select the size of the the data a model will basically use for, so that is also you can select. And libraries that are supporting basically you want to check, that is also you can select. But right now we are mostly focusing on text generation. Okay, so I will click on text generation in the filter. So you can see these are all for the text generation, and also I will click here inference available. Okay, so inference available means there are some models that provides you inference with some limitation, so you can make API calls on that. So you can see these are all models that are available for us. Okay, so let's say this DeepSeek AI, so you can click on this, use this model, go to inference providers. So you can see there is a curl request as well, so you can make API calls to this model, and there is a token you need to provide that we have generated just now. Okay, if the token is not working, what other thing you can do, you can create a new token with the read permission. Okay, but I am sure like what we have selected, it will also gonna work with that. Okay, so this is kind of our limitation. We cannot use any model because that requires some resources or GPUs. So yeah, that is the case. But if you are working in a company, or if you are building any project for your customers or client, they will provide you like they will provide you tokens, or there will be their headache to provide you the models that you want to use. So there is like meta models. So these models, okay, that are available. So let me search here meta. So there are lots of models for the meta, like this one EDB-instruct. So this is also providing, but there are some heavy meta llama models that doesn't provide you inference. So for that you need to deploy that model to your own GPUs. So this is also providing. Okay, so you can make PI calls. So what we are doing earlier, what we have selected, text generation and inference available. Here we will pick some models because we want to implement multi-model system. Okay, so you here you can pick anyone, or while building the project I will let you know what model you need to pick. Okay, so only token generation part is what important here for us. And one more thing, like you cannot choose any models directly, okay, because every model come with their specification, and those specification given by the model trainers, I mean to say, like whoever created or fine-tuned that model, they will give us a specification like, hey users, this model is basically more more good in this specialty. Okay, so as we don't have time to go over those documentation and all that, you can ask any cloud AI, or any kind of AI tool to give you the best LLM providers or best model for your use case. Okay, you can explain your use case to your AI, okay, and then it ask for give me the list of models that will be suitable for this use case. Okay, so that's what I have mentioned over here. The reason is choosing the right model matters because it will give you higher accuracy, better performance and cost efficiency, and lower hallucination and better user experience. So currently, one more thing I would like to explain you if you don't know what is hallucination over here. So every company right now, or in the world, you can say everyone is just chasing a perfect zero hallucination AI model, but that is not possible because if I give you example, let's say if you are building an editing application, okay, there you can edit with some AI tools. So let's say you have asked your AI tools to edit a image somewhere, okay, or there will be some functions in your applications. So AI will first go to your one of the function, he will execute it correctly, okay, but if you ask again another query, then AI sometimes what it does, it assumes a function based on his based on its previous context. So let's say there is a function called remove background, so it will automatically predict like there will be also a method for remove remove color or anything like that, but that method is not exist in your system. So that kind of hallucination is the problem currently in the world, that everyone is every AI developer is trying to reduce it. But I think that is something like we are chasing for the perfect thing, but only thing we can do, we can lower the hallucination, okay, and that can happen only choosing the right model, and it will give us a right answer with the lower cost and better experience. Okay, so here you can see for question answering there is this one model Meta Llama 32 P instruct. Why, what it needs most, basically factual accuracy, concise answer, general knowledge. Okay, for if you are using any code generation kind of syntax or any, then Quinn is one of the good model, then reasoning, DeepSeek. Okay, I'm not saying like only these models are capable of these categories, there are other and there are better as well, but for now our use case we are using the free inference API available, so that's why we have chosen this. Okay, and if you choose the wrong model, it will give you more bugs, wrong code. Okay, using a code model, it will give you irrelevant answer. So this is how basically your business will be impacting if you are developing any product or your any kind of thing you are developing for yourself or for the company or anyone else. You have to choose the correct model. Okay, otherwise these problems you will going to face. So yeah, this is what I wanted you to explain on the models, and I think we are done with the external things what we need to set up. And you can do one more thing, you can do python hyphen version, node hyphen version to check out like the things are correctly installed or not, everything is in the environment variables or not. So once you are done, let's go to create our Redis and Elasticsearch container. Okay, so for setting up Redis and Elasticsearch container, there are two ways. Either we can use commands to pull, then set up volume, set up networks, those kind of Docker steps, Docker commands we need to run. There is one more way that we can create a YML file and we can simply compose that YML file using podman compose or using podman, and then all the steps will be done. So here we'll just create, and one more thing, create a folder on your desktop or anywhere you like to do this project with me. Okay, and then open this project in your VS Code and create a file podman compose.yml, and in this we will be defining the steps we need to perform for Elasticsearch. Okay, so before that I know like many of you might not have good knowledge about Docker, so I would like to give a short explanation on that. So basically container, what is container? So a container is basically a running instance of image is basically like Redis image or Elasticsearch image, and it is a isolated, lightweight, and contains everything needed to run on the application, that create a separate isolation from your system. Okay, so everything that is need to run this Redis, it will be packed in this container and it will be running as a in isolation. Okay, and what is volume? Volume is we use for persistent storage, and network is used for enable containers communication with each other. Okay, and ports is basically on which port of your machine you would like to see the services up and running, so you can define that as well. Okay, and there's environment variables you can configure like password, etc., or any kind of application related configuration. And image is basically a read only template with application and dependencies. Containers are created from it. Okay, so image is basically, inside that image there are lots of you can say binaries or lots of files are there that is used for extracting on the isolation environment, and then it will launch and provide you that application. So application in the sense like Elasticsearch or Redis. So this is what basically acronyms. Okay, and you can see network like from Elasticsearch to Redis, that both these containers should communicate each other, and you can define the port, or you can define the environment variables, and this is the official image name. Whatever you want to pull from the Docker container, you can pull that. So these are public images provided by the official Redis and Elasticsearch team. Okay, so how I know this is the name of the image? You can basically Google it, you will get to know. Okay, and this is basically what we want to implement. Like on our host machine, we want to access these containers on this specific port, and inside the container there is a multi network bridge that makes these two containers to communicate with each other, also having access to the outside of the internet. Okay, internet in the sense our machine. So, and how the Docker file is basically looks like, or you can say Docker compose or podman compose. Okay, both are same, but Docker is a different and podman is a different. but the YML file creation is same. And YML file is basically a serial, like a serial generation of steps and commands that basically used for mostly CI/CD or pipeline. Because if we do these steps from the commands, there will be lots of commands you need to write, but with this compose YML file you are just defining one file and all the steps will be done. Okay, so you can see we are defining the YML file version that you are using. In the services we define the container, so one container is Redis, and indentation is important. Here is the name, image, the official image name, and container name you can give it whatever you like to give, and the ports also, you whatever ports you want to see this container or service up and running. And volumes is basically for processing your data. Let's say, for example, let's say you turned off your computer and reopen it, your data shouldn't be lost whatever you have done. Okay, so that kind of thing are done under volumes. And environment variables, here we are passing a specific password in the environment. Redis password is the password for accessing this service. Okay, but basically on the CI/CD these kind of passwords are hard, as a argument they are getting passed. You cannot directly hardcode over here, but as we are developing we can hardcode. This is just for our practice. Okay, and restart, basically if there is any crash or anything, it will automatically restart. Okay, and networks is under multi-agent network, it will be also linked, and same we have defined over here as well. And these are the configuration and things for Elasticsearch, and these two volumes that we want to persist. And this is the network type, or a bridge type is bridge. Okay, so internally these can communicate. So just write all these things in your this file what we have created. So let's write. So once you have written these files are basically generate from any AI or Claude, whatever you are using. Okay, so make sure these configurations are there, and after that we will run this command podman compose, and the file name podman compose .yml. so this podman compose is basically a command line. If once it is installed, you can run this command podman compose -f podman compose yml and then up -d. Okay, so once it is pulled up and once it is ready, it will be available and up and running. So as you can see, once it is done, these both containers are up and running. You can go to your podman desktop and go to the containers tab over here, and you will see these two containers are up and running. And if you want to see the logs, you can see that logs as well. Okay, so yeah, this is something needs to be up and running. And now we are done with all the external stuff that like we need to back and forth jump on code, then a browser or any other stuff. That is done. We don't need to now go anywhere else. We will just focus on this VS Code. So here just create a folder backend and one more folder frontend. Okay, so here first of all we will check Python version. So currently we have installed 3.14.6, so it is there. And now we will go to this backend folder, and in this backend folder we will create a virtual environment. So virtual environment is same like node modules in node world. Okay, so basically everything related to this project, all the dependencies, libraries will be installed in the virtual environment. Okay, so how to create virtual environment? You have to just run this command python -m. Okay, give it a name of the virtual environment. So let's give it .vnv and hit enter. You can see our virtual environment is now created. Okay, so once it is created, we will create here some files. Let's say requirements.txt. So this requirements.txt is same like package JSON file in which we have listed all the dependencies and libraries with their specific version. Okay, so here we will be using FastAPI, then UVCon. Okay, so and how I will know like which library I need to use? Simply just go to Google, search for Python UVCon library. Okay, so you will go to this documentation, and here you can see this is the latest version. Okay, and if you want to install, just do pip install UVCon. So this is how basically you can install. So let's do that. So here we will be installing UVCon, then we will be installing FastAPI. So just copy this. So this is like a npm same like Python package manager. So where you see all the packages. Then we will be using Pydantic model for the schema validation. So just copy this. So this is Pydantic, and we will be using Python .env to load the environment variables. Okay, so everything we are using here latest, and while building the project you will also do. It doesn't matter when you are watching this video, just install the latest stuff. Okay, Langchain, this one, sorry, Langchain. Okay, so I will write Langgraph. So Langchain framework is for LLM application, and Langgraph is for workflow orchestration. Okay, I will let you know in detail. For now, just let's install this packages, and we will be using Langfuse, then OpenAPI. Okay, OpenAI for the Llama service API calls, then Redis, then ElasticSearch, then HTTPX for the client API calls, and then there is a PyJWT for JSON Web Token Management, and passlib is basically a password hashing package, then email validator. If you basically we will be doing the email validation, so you can install. This is one of the easy package, and just hit enter. Okay, so now notice one thing. I will cancel this. So this is basically getting installed in our global Python virtual environment. Okay, so we don't want that. What we will do, we will first activate this virtual environment. So the command is basically source dot venv, and in this we will go to bin directory and run just activate. So this source is basically this terminal on which this environment will be activated. So bin activate. Okay, activate dot sh source slash bin slash activate. Okay, so here it will be dot slash dot venv activate, and you can see the environment is activated. Over here you will see dot venv. So we are now using virtual environment for this, and now we will run the command again, and all these libraries now it will be installed in this lib. Okay, so everything will be gonna install, and you can see it is getting added over here. So all the libraries, all the APIs, everything. So this is what is the meaning of virtual environment, and I think it is taking as a new command, so we don't want the new command. Just yeah, yep. so everything is installed now. And if we go to so after getting installed, how we will see in requirements.txt, so that when we share our project with anyone else, they will also able to install the specific version. So for that, so to create requirements.txt file, we will first release this one. I was just explaining to you what is requirement.txt. So there is a command pip freeze, and this angle sign, then requirement.txt. Okay, so just run this and you will see in the backend there is a requirement.txt file created, and in this requirement.txt file you will see all the libraries that are that is getting installed. Okay, so all the libraries is now listed. Now if you share this code with anyone, they can also install all these things using this command. So the command is basically pip install -r requirements, the file name basically, and then txt. So it will also go to your requirement.txt file and then start all the installation. Okay, so this is Python package manager, and pip is basically just same like npm. It is used. Okay, now it's time for building our project, but before that we will create a .env file in which we will be keeping all the environment that we needed for our project. In .env, first of all we will put the app name, app.env, and API prefix. Okay, so this will be the value, and there will be backend course origins like we are aligning localhost and the IP. Okay, and we need to provide LLM provider. So LLM provider we will be using Hugging Face, and then you need to provide Hugging Face API key that we have saved while while developing in the earlier when we are registering on the Hugging Face. So that API that you need to paste it over here. Don't use mine, it will be deleted. And after that we will be defining which model is used for which task. So as I have earlier told you, so we will be using for summarization this model, code generation this, question answering and reasoning this model. Okay, then we will set the Redis configuration. So in the Redis there will be a Redis URL and it is running on 6379, and this is the Redis password. Why we are putting this? Because we know what we have defined in the podman file. Okay, so you can see we need to pass the password, and this is the port it is running on. And this TTL second is basically after how much time your Redis will be time limit. So you can define, by default it is this value, so it is correct. And after that you need to enter Elasticsearch configuration, so Elasticsearch URL, and you can enter Elasticsearch index like any name, starter documents, and user will be Elastic, and password what we have set is change me. Okay, so in the Elasticsearch we will run this command to create a user and password with this value. After that you will need Langfuse configuration as well. Go to cloud.langfuse.com. so here you need to create your account. You can create using GitHub or anything whatever you want. Okay, so I will create account using GitHub, and I will authorize Langfuse. Skip. Okay, so actually I have already created one account earlier. So over here you won't be seeing any organization, so click on new project and create your organization. Okay, and after you created the project, go to tracing, create a new API key, and you will get this secret. Okay, just copy this .env and paste it over here. So this will be there. Apart from that you need to enter other configuration related to Langfuse, like Langfuse enabled or not, Langfuse host. Okay, and we will use Langfuse environment will be production, and user ID will be user-dev. Okay, so mostly these three are important, but this we have added for our own configuration that we are going to do in the code. So one more thing I would like to mention here, like I am developing this project in a very concise way, like I'll be explaining everything, I'll be coding. So there are multiple ways. When you understand fully how to develop a AI project, then you can do anything. You can first build the app, then create .env file. Okay, so the way can be multiple, but I prefer this way. So we don't need to go back and do extra stuff that is unrelated to our this VS code. Okay, so that is why I'm doing those stuff over here. So anytime uh, when our API is getting called, we will see those in our tracing. Okay, so you can see it is waiting for the first trace, and whenever we using the Langfuse library, we will trace our LLM, then we will see the tracing over here. Okay, so this is basically for the authentication, like login authentication that we have. So this will be a base64 secret and algorithm what you are using, and the token expiry minutes. You can play with this or change the value. Okay, but don't change the algorithm. So yeah, so far this is your .env, and now over here we will create one more file like .get ignore. So in this we will define .env. Okay, we will define .env, and we can do git init. So git is initialized. So this stuff are essential, and here we will create one more folder, data app sorry app. In the app we will keep everything related to our services, and we will create one more folder that is scripts. Okay, so now in the data there is a CSV file. So AI tooling catalog.csv file, this you can create, and you can put anything data whatever you want to ingest in the Elasticsearch for fetching out, and then AI will respond and summarize this data. So I have generated this data from ChatGPT. So you can go ChatGPT and ask like create a CSV file or give me a CSV file for this kind of testing. So here is the CSV file, and this you can see 4 columns: title, snippet, category, and source. Okay, so yeah, this is the data. You can increase it accordingly. So before doing anything on the backend, let's set up front end also, because in front end we are not going to code or do anything. It's just that it is used for our testing of our services. Okay, backend services. So in the front end, as I have provided you code, you can check in the description. So you can just same copy over here and create a file in this env dot local. Okay, dot env dot local. So this in this you can just put this URL. So on this port we will be running our backend services. So let's go to front end, then npmi npm run dev. Okay, so why we are so it is successfully installed and up and running. Let's go to this port. So meanwhile it is installing and up and running, you can do one more thing. As this is a mono repo, kind of we are building, so you can get initialized in the main, so it will be considered as like main repository, so you can pull front and back end both code in your GitHub. Okay, so as we can see, it is running on 3000. Let's go to the browser and check. You can see currently everything is offline and provider is unknown, so these all status will be coming from our backend. Okay, so yeah, now I think we don't need to do anything on the front end is ready, we just need to build our backend. So in the backend we have done this data. Now in the app, let's create a file main.py. So this main.py file will be used for initializing of our backend server, basically the FastAPI server. And let's create folders, and I would like to explain you a folder structure that I'm going to use over here. Let me zoom in. So in the agents we will define everything related to agents. Okay, so there will be summary agent, or so whatever the agent logic will be in this folder. Then we will create one more folder, config. So in the config, if there is any configuration related to project, so for example we will load all the env file, okay, in this configuration with a file called settings.py. So yeah, this folder is used for that, and there will be data ingest folder. In this data ingest folder we will be creating a file csv ingest in which we will be ingesting the data, and there will be dependencies, so you can say shared dependencies. So in this one we can configure our authentication, and there will be memory. Okay, so in the memory we will be keeping all the files that is related to Redis or storage. And there will be middleware. So middleware is used for authentication, and if there is anything rate limiting or security headers, so all those things will be in the middleware file. Then there will be routers. So routers, basically we will be defining the routes, basically the API, how many APIs we are going to build. And in the services we will keep services like LLM services or Elasticsearch authentication. So it is like a wrapper. Then there will be state. So in the state we will manage our LLM state, the workflow orchestration state. Okay, and there will be utils folder also. So in the utils, as you know, any utility we can define. Then at the last there is a workflows folder. So in the workflows folder we will be creating our orchestrating workflow. So everything related to that will be in this file. So I hope you understand basically how the folders will be created and going on. And now let's start with creating our what I was talking about is this configuration. So first of all we will put all the envs using this file settings.py. So every file in Python is created as .py extension. Before jumping on the code, I would like to explain you these concepts that you will be seeing while developing the project. So in every folder you will be seeing this file we will be creating hyphen underscore in it, then again double underscore .py. So what is it? It is basically tells Python that directory should be treated as a package. Okay, in this init file you can define what kind of import you are doing, what kind of wildcard imports you, so everything you can define. Okay, so you can see if we directly create this folder, then it will not recognize this Python package. can it use from utils import helpers? Okay, so let's say in the check.py you try to import helpers, any function or method from this utils package. So you cannot do that. Okay, that's why you need underscore init dot py file. Then it will be recognized as Python package, and then you can import. Okay, so this is one of the Python requirement. Either you can keep init empty, that is also fine. But if you want to define or if you want to write any docs, you can do in the this package itself. Okay. So this is basically underscore init.py, and there is one more library, Python library, that is Pydantic model. So it is used for basically data validation and settings management using Python typings. Okay. So you can validate data at runtime. You can parse data. Parsing means like JSON to schema data, then schema to JSON. So you can perform this kind of thing with Pydantic easily, and it will auto generate schemas for you if you are using that. And it is great for APIs and configurations. So you can see how it is used. It is used basically, there is a base model in the Pydantic class. You can directly import it, and then you can use inheritance to extend it, and you can define these are the things that are available in my class, user class. And what a Pydantic model will do, it will automatically create JSON for this schema what you have defined over here. Okay, so you don't need to explicitly do any kind of configuration or make any this curly braces kind of thing. This function user dot model underscore dump will automatically do that for you. Okay. And one more thing, in there is a literal. So literal allows to specific values. Okay, so literal is also one of the package that you can use. So here you can see we are setting a mode of fast and slow, and print set to mode. So here if you set mode fast, it is valid. Set mode slow, it is also valid. But if you are setting mode medium, then you will get a type check error. Okay, so these kind of specific literal value or constant value, if you want to apply on your function or method, you can easily use literal over here. You just need to import class from it, and you are good to go. So it is available in this typing util package. Okay, and these are the benefits of it. And yeah, so here there is a list also you can import from typing. So list is used specifically where item is a type of T. So T is a generic inside this list. Okay. So basically you can see if there is some kind of list you are building, so there is an array over here. Okay, so in this array, if you are multiplying from anything, then you are returning anything, so that will be as in list. Okay, so this is something basically used for type checking. Okay, and you will get fewer runtime errors that you are seeing in this benefit. So this is why list this typing is used to make sure you are passing passing correct data types in your function or methods. Okay, and there is a base model we have seen in Pydantic. So base model is the core class in Pydantic. You can create models by inheriting from it. So here is the model, okay, that you have defined, but when we inherit it and extend it, you can easily um, convert and serialize the data. So these are the benefits of it. It will do schema generation, that is immutable and configuration optional. And nested model support, it will provide you type validation and different values. Okay. So if we see over here a validation error, so you can see we have two ID and price in the product class, and if we are giving ID as a string, then we will be getting validation error. So these kind of stuff you can uh, use Pydantic for schema validation. Okay. So far, I hope you get that what is Pydantic, why hype underscore init file is what is list and what is literal. So let's use this thing in our settings.py file. So here we will be importing first of all OS. Okay, why OS? Because your code can be deployed on any operating system. So you have to make sure that you are writing code that is not specific to MacBook or not specific to Windows or Linux. So it will be supported for every operating system, and we will be importing typing. So just like our React Native or React.js, we usually write import list from typing, but in Python you have to first write from which you are importing, and then after that you have to define what you are importing. Okay, so from typing we are importing list and literal. Okay. What is happening? Then we are importing .env from the package that we have installed. Okay, so there is a Python. So when you type over here, you will get all the list. env. So Python. Let me check if we have .env requirements or not. .env 1.2.2 is there. Okay, so let's see. Getting started. Yeah, we are importing correctly. I think this is just a warning. Okay, so there is a we are using extensions also. So there is an extension you need to install in your Python. I have missed to tell you. Okay, so sorry for that. And the extensions are Python environments, then Python debugger. So everything related to Python you can install. Pylons, Python debugger, or indent also you can install for correct Python indentation. It will help you. So for the demo, if you are writing something like this, and okay, and when you save, it will automatically do that for you. Okay, so once we imported this, we need to call the function load.env. Then we will go down and create a class over here, class settings, and then we will be inheriting from the base model. So let's import base model also from Pydantic. Let's import it. So it is not picking up our path. So also command set reload window. Yeah, it is reloaded. And now you will see okay, so use this. Yeah, now it is gone. So again you will need to go to select interpreter and you will need to use this interpreter what we have defined in our settings.json. So in the settings.json, you can see interpreter path is venv, bin, and then Python, and analysis extra path is this backend folder. Okay. So now there is no such errors. Um, so here we will give it a name, app name. So basically whatever we have defined in our env file, we will be loading envs. Okay. So you can see we are calling this os.getEnv, and this is a type you can define. So as a string we will be getting this, and this is a app name what we have defined in our .env file. You can see app name. So same you have to use it over here as well. So this will be your app name, then this will be your environment, and this will be your API prefix. Okay, and this is your origin setting that we are picking up from the backend course origins. So yeah, these are the thing, and after that we will be picking up LLM provider. So LLM provider, what we have defined, that is Hugging Face or Ulama. So from os.getEnv it will fetch, and this is the default value. Okay, if we are not able to get the environment, we are setting this value. Okay. So Olama base URL you can use over here. So this Olama one is basically in the starting I have told you when I have used two laptop, and one is serving the Olama model and another we are creating the backend. But if you don't want, that is also fine. So this is Olama configuration. Then there is a Hugging Face configuration in which we are picking our Hugging Face API key and the model. Okay. So you see we are not putting default value over here because that is a sensitive information. And after that model summarization env we will load. So yeah, this way we will be loading it. So these are the four values that we are loading from the .env. And if anyone from you are saying like bro is doing the copy paste thing, so the reason is I'm doing because the time when we are doing line by line code has been, that is a very old era, because now we are in the AI era. Okay, in the AI era, every code can be written by AI. So our main point is not writing too much code. Our point is to understand the code. Okay, even if AI is writing, and if there is any failure in the future, we should be able to understand where we need to fix it. Okay, so that is our main goal as a developer. So yeah, this is the Elasticsearch, and then there will be Langfuse. So whatever we have set, we are importing it and assigning the values in a variable, and the last is authentication one. So yeah, everything is done. Now what we will do, we will do settings. Okay, so if you go at the top, you can see we will be exporting is equal to settings. Okay, also let me check, there is a extension we can download from Python. Yes, so most of them are already there. If you want to define, you can define it as settings. If if you want to add a type check, you can do like this. So this export is a type of the settings class. Okay. Now, after creating this, we will create a under underscore init.py file. So this is how it will, this config will be considered as a package. Okay. And then you can import this setting class anywhere you want or wherever you want to use this environment variables. Okay. Now after this, we will go to the folder models. So I think I have missed one folder. So there is a models folder in which we will define a schema. So I will copy this init and paste it in the models. And here we will create auth models.py. Then I will create other models as well, but let's first write some code in the auth model. So this is a very simple one. I will explain everything over here. So in the auth models, you can see we are importing base model, email, string, and field from Pydantic. Okay. So if you hover on email str, you will see this is a string object that we can verify for email, and this is a field in which you can define whatever you want to define regarding the input. Okay. So you can see this is a basically field is basically a type check or condition. If you want to add on any of the input field, you easily use this field import. So there we have created one class register request. So register request, and whenever you are calling this register API, you have to pass email as a string and password as a string, and password should be minimum length will be 6. Okay. So same will be for login, and for token response we are giving response to the user as string of token. Okay, as a string, and then token type will be bearer, that we by default defining it over here, and email will be the user email. Okay. And this is the for the user response we have defined. And after that we will create the ingest models.py. So ingest model is basically used for the Elasticsearch, like how we are indexing the data in Elasticsearch. This is a small class in which there will be index count, index name, and source file. Okay. So these three things basically required for calling the ingest API. And there is one more model we need, that is chat models.py. Okay. In the chat models.py, we will be importing multiple things from the typing for the type checks, and base model and field from the Pydantic. Okay. So here you can see for the chat message there will be a row, messages from the user or assistant or from the system, and there will be some content. Okay. So same we will create for the chat request when user is prompting something. So it will be a message, then what is the conversation ID, if there is a history of the messages. Okay. And by default we are adding a in the message field, conversation ID will be optional but as a string, and by default it will be none, and history will be chat messages. So this is a list. List is basically in Python, a kind of an array in which you can define multiple iterative data. Okay. And this is a field what we have added, that it should be a list type. Same for the search result. when we call the search agent, so it will be returning this to us. What is the source that search agent has used for finding out anything data that user want to know. I'm really sorry the mic got disconnected. So I hope voice would be clear now. So basically what I was doing from last 25 minutes is creating these models and having like what data will be getting passed when you are making a API call. So basically that we are defining here. Okay, so there will be no wrong data will be passed in the API. So these kind of type checks we are doing, and in the settings.py basically we have loaded all the .envs that we have defined in the .env file. Okay, so yeah, so in the chat model, when agent will be returning any response, so it will be returned as agent and whatever will be the output, and if there is any metadata it will be also there, and it will be type dictionary. In the dictionary there will be a string and the value will be any. Okay, and default factory will be dict from the typing what we have imported. Okay, so these kind of type checks what we are doing, and this is the chat response that will be sent to the um, chat response to the user. So there will be conversation ID, route, answer, what agent we have used. Okay, what is the agent result, cached, and how much context messages is like if you have any previous query, then there is another second query you are prompting, so that context messages. So it is used, this chat response is basically used for the next next chat that you are going to do with the AI. And there is a conversation context response. So this is basically used to store all the all the context or all the questions that you have asked earlier, and that AI has responded to you. Okay, so let's say you have asked a question like, show me national bird of India. Okay, or tell me the national bird of India. It will tell you, and again you are asking like again you are prompting only for game. Okay, so how AI will now understand that you have just prompted game, and earlier query was tell me the national bird of India. So in the second query you just have written game, so that context will be assumed using this responses, and the next query will gonna become tell me the national game of India. Okay, so these are chat models, and we are done with the models also. Now it's time for moving further. We will create our service layer. Okay, and models creation is comes first, because when you are creating API you will be using this model, so you cannot first create the services then define model. So the flow that we are going right now is the best flow. Okay, and now let's go to the services folder and create over here service auth. First of all we will define auth service.py. Okay, so I will copy this init over here and this as well. Let me do one thing, let me copy to all the folders, so we don't need to again do anything. So this init.py file I have put everywhere. Now backend app services auth services.py. So in the auth service we will import JSON. Okay, and let's import multiple other stuffs like optional from typing, and we will be importing Redis memory service. Okay, from this app, then memory, then Redis memory. Okay, so for that we need to create one file and the memory. So this Redis memory service is basically that will hold all kind of storage management in our app. Okay, so basically we are not using any database like SQL or anything for storing this kind of stuff. So as we are learning right now, we can use Redis to store everything. So in the memory, I will create a Redis memory dot py file, and in this we will define some functions. So import JSON and this stuff type checking from the typing, and then let's create a class Redis memory service. Okay, so in this class Redis memory service we will define and init. So um, these are some syntax of Python. So this is how basically you define and initialize the constructor. Okay, so that thing you already know in oops concept. So in this we are defining there will be a string, and there will be this time limit seconds. Okay, and in this we will be defining self.url will be self URL. So the same process that we usually do in all the all the kind of constructor in any language. So we are assigning TTL seconds whatever we are getting in the response, then client will be none initially, and there is a memory store. So this memory store will be a dictionary. Okay, so dictionary is like a JSON in which there is a key and then there is a value. So key will be string type. Okay, and this entire dictionary also a list. So and this list, the value of a key will be a list of another dictionary. So it is like a nested JSON. Okay, and there we will be storing kv store. So this is also a string type. Okay, and now let's define a try catch over here. So try catch we use for exception handling in Python, and the syntax you are seeing right now. And one more good thing about Python is you don't need to import on the top anything. Okay, if you want to import something in between the code, you can do that. So you can see right now I'm importing import lib. Okay, this is one of the library that we are using to import a module. So here we will define Redis module equal to import lib dot import module, and the name we need to pass that will be Redis. Okay, so this module we are importing the smaller. Okay, then we are initializing this to the client Redis module dot from URL, and URL will be the URL that we have defined in the .env, and then it will be decoded responses will be true. Okay, and we will once we are connected with the Redis client, we will do the ping. So ping is one of the Redis health check call. If you want to do, it will give you output pong. So ping, if you ping a Redis client, it will output pong. So basically it is up and running. Then self, if there is any exception in the client connection, then we will mark the client will be none. Okay, so none is basically not null or anything. None is basically there is nothing assigned in this client. Okay, and then again we are defining one more method over here, conversation key. So in this conversation key, basically there will be in the Redis we will be storing conversation key, like there is a string conversation and then there will be conversation ID. Okay, so notice one thing over here, we are using this f string. So f string is Python 3 point something, it is introduced, so in which you can do string manipulation in and include variable directly. Okay, so every conversation we will be storing in Redis like this. So conversation, it will be having conversation ID and there will be messages. Okay, and for user, let's store user key. So this is also email, etc. Then there is a fetch methods as well. So let me explain you. So in get messages, you will pass the conversation ID and it will output the list of dictionary string JSON basically. So if the client is initialized, so first you see we are checking if the Redis client is ready or not. Then we are doing the try catch, and in the try catch we are using this lrange function. So this lrange function is coming from the Redis itself. Okay, in which you are passing the conversation key that you have this is basically a conversion of conversation ID, so it will be converted like this, and after that you are fetching all the messages from 0 to 1. Okay, so if we see lrange function in a Redis client, you will got to know like there is a limit that you need to provide. So from 0 to -1, whatever is there, we are fetching it out and using JSON, this JSON dot loads. Okay, so this syntax is quite compact. In this, what exactly we are doing, we are creating a list. Okay, in this list we are iterating over items. This is a loop running inside Python. Okay, in which for every item we are doing the serialization, or basically we are converting basically from JSON to this list type. Okay, so this is one of the Python JSON you can use to convert the data into list of desired this type. Okay, and if there is any exception, then memory stored that get we will, so there is a chance like there is no messages then or nothing is stored, we will output empty. Okay, or if the client is also not initialized, we will directly return the empty conversation ID list messages. So I hope you are understanding. Basically we are defining the memory stuff, how we are storing messages, or extracting it from Redis. So these kind of stuff we are doing. So this is a append message. Let's say you prompt something, then there will be a payload. Okay, so role will be whatever role, like it will be assistant or from user or system, and your message. And if the same thing, if it is initialized, we are dumping the payload. Okay, so here you can see the payload is in the this JSON format, but when we use this dump, it will convert into JSON formatted to string type. Okay, so this object will be converted into a string and it will be stored in the Redis, and you are setting after how how much time it will be automatically expired and removed from the Redis. So this is the TTL second is used for, and then you will return from this function. If there is any error, we will pass this, we will not do anything. Okay, and in this self dot memory we will set the first message. So this is what we will be doing in the memory store. Now after this, there is one more method if you want to clear out all the messages. You can add a clear message method, and in this one there is a function delete, in which you will just pass a conversation ID and it will be deleted. And if you want to get a value for, let's say, user, so for that there is also a method get value return exception and the key store dot get key. Then there is a one more method to set value that we need to define. So this set value is used for basically the key value pair in Redis or in memory state. So this will be used when we are storing on the messages. Or okay. So there is one more method we have added, set value, and this set value in which using this is a comment basically in Python. If you want to add comments or if you want to define basically what this function do, you can define under this triple dot. You can see when any user hover on the method, they will see this clear documentation what this function do. Okay, so this function we have created to store user information, and in which we are setting the time limit to -1. That means time limit will be set for I mean there will be no expiry. Okay, because we don't want user to do again sign in, sign up, these kind of stuff. So once user created his account, he can enable usually login in the app anytime. So this is a property decorator in which we are defining using Redis in the self of this class. Okay, so this will return a boolean, and if this is not initialized, then is not in none. That means self is not in none. Okay, so that means if client is not none, then it will return true. If it is none, then it will return false. Okay, so these are some basic Python syntax that you can ask chat GPT or any AI tool. You can usually understand what we are writing, but my point is here to explain you why we are doing it. Okay, and what are the things. So you can easily understand this syntax, and we are done with the Redis memory. And now you can see we are using this Redis memory over here. There is no such errors. But one more thing, even if we delete init file from here and if we again write it, you will see there is no such errors, but still it is recommended to define .init file. Okay, maybe it is not showing in this pylance. Okay, but maybe when we compile the code, when we run the code, it will be show to the user. Okay, so on the auth service, we will create a class auth service. Then we will define here constructor self, then memory service. This will be type of Redis memory service, and in this we are assigning the memory service and assigning the memory service value. That's it. Okay, this is one of the constructor that we are doing. Now in the register user method, what we are doing, we are passing the schema of a register request. So you see we have defined in the models all this schema, so you can directly import it from the app models and auth models that we have created. So register request, and the type of this will be user response. So key, let's add key self dot memory service dot user key, and let's pass user email. Okay, And let's check is it existing or not. So self.memory service dot get a value that we have just now created. So we will get the value. If it is existing, then we will raise the exception. So in Python, you can raise the exception using this raise keyword, and you can define a value error. So user already exists. Okay. If it is not existing user, then we will create a payload. So payload will be like JSON request dot email. Then we will be having a hashed password we are storing. So just like Express.js, uh, you can hash the password. So for that, we can create one utility over here in the utils. So let's create a utility file security dot py. Okay, and in this we will be using this passlib that we have installed, and from it there is a context, and we are importing crypto context. And in this you can define the algorithm and deprecated auto. This basically means if there is any error or schema is deprecating, you can usually store it. Okay, so in this we are getting the context, and after that there is method we have written hash password. So password consec dot hash will give us a hashed password, and if we want to verify the hash password, you just need to verify with the password, okay, and the hash password. Okay, so this password is basically what user has entered, and this is what basically we will be fetching from the Redis. Okay, so now back to auth service, and hashed password will be hash password. Oh sorry, let me import it. So we are importing hash password and verify password for login, and in which we are passing request dot password. So payload is created. Now self dot memory service set value will be key. Then we are using json.dumps to serialize it, and we are passing the payload. It will be converted into a string, and TTL we are setting -1. -1 means it will be, there will be no expiry for this data, and we will be responding user response. Email will be like request dot email. Okay, so you can see how user responses look. It needs to have this email string, and while wrapping this in a response, it means we are applying the validation. Okay, so this is register, and then let's create a authenticate basically the login. So for login also you will be passing us login request, in which there will be email, there will be password. So we are firstly checking it, are you logged in or not. Okay, so if there is no stored user, we will return none from here. Okay, and there is, if a user exists, then we will loads the stored user. Loads means we will convert back to JSON, and we will check request dot password and payload. Then we will verify. If it is not verified, you can see if not verified, then we will return none. Otherwise we will return the user response. Okay, and there is one more function we are defining, get user. So let's say you are already logged in, then we will just refresh your environment so you can get using self memory service user. Okay, so this is so far in the auth service, and now we can create a router for it. So let's go to the routers folder, and create here router auth underscore router dot py, and in the auth router dot py we are importing but I think we have left one more thing to do, that is token service. So using token service, we can do JWT stuffs. Okay, so user will make API calls. So for that you need to go create a file token service and services, and here you can see we are importing date time, time delta, time zone from date time, then any and dictionary from typing and JWT, and from the settings we are importing these settings what we have defined. So you can see in the config file we have defined this settings. Okay, so that is imported, and now create a class token service. So in the token service class we are defining create access token. So access token will be created like this, in which we are defining the expire set, okay, with using time delta, and these are auth token expiry minutes from the env, and this will be UTC time zone, and this is how your payload will be look like, and we will be encoding this data in the using JWT encode, and this is how in which you have to pass the auth secret key and then the algorithm. What we have, these two we have defined in the env file. Okay, and this is a payload that will be encrypted or encoded, and after that this will be used when you are trying to make a API call, then we will use this decode to check are you a valid user or not. Okay, so this is token service. Now back to auth router. So in the auth router, let's import lots of stuff. Okay, so we will be importing logging over here, we will be importing FastAPI, API router, HTTP exception status. These are the NV settings, these are the memory management Redis service, these are the models that we are going to use for validation, and these are services that we have just created right now. So once it is imported, go create a router, API router using this from FastAPI. Okay, so this is a class. If you want to see how you can define it, so you can see this is a decorator, and this is how basically we can define it. So API router, we will prefix this with the API prefix that we have added in the env, and then this is the API path, then tags will be auth. Okay, now logger, we can use logging dot get logger, and in which we will passing the name. So this is basically the logger mechanism what we are importing it. Okay, so while running the 8000 port, we will see responses like from if there is any error of if the user is getting successfully logged in, so that kind of stuff. Now let's import the classes of the services that we have created: memory service, auth service, token service. Okay, and once you import it, now using this decorator router, so it is same like I think in the Express.js or Next.js we used to do with the decorator. So this is a post request that we are going to create, in which register will be there, then response model will be user response, and then a status code will be status dot http 201 created. Okay, so this is what this post request will do, and let's define how it will be done. So register will be having a request, and that will be register request parameter, and then it will output user response. Sorry. So in this, let's add first of all a log register request received, then extra variables you can define like user id will be request dot email. Okay, then you don't need to do anything now. Whatever auth services we have created, just use try catch, in which we will uh, pass the request in the register user a method or function that we have created, and it will, after registration complete, we will log it, and we will return the user. If there is any error, we will simply log that error as well. So yeah, so if there is any exception value error, as I mean, we are aliasing this value error in a short form exe, and that will be, we will be printing over here. Okay, and we will be returning it wherever this API is getting called, and same we will do for login. Okay, so I hope you understood how FastAPI router works, and these methods are already provided by FastAPI, so it is very useful for us. We can usually use that. So this is the token response. If you are successfully logged in, we will be sending you access token. Okay, and you can make it more complicated with refresh token or other stuff, but yeah, we are already here for AI learning, but we are dealing with Python fast API. So yeah, that is fine. It is like good for your learning. So there is one more router we can create over here, health router.py. In this, let's import this services, and we will import Redis. Define router, API router, health, memory. Let's create a variable memory service, in which Redis memory service. We will be passing this stuff, and then there will be we will create a router dot get health API slash health. So in this, you can see we are not adding any kind of prefix. Okay, so def health, then dictionary, string type, and object. It will return, and in the return we are expecting, why this is popping up again and again. So in this, we will respond status, app, environment. Okay, LLM provider, Redis is connected or not. So these stuff we will be uh, outputting. Now it's time for creating the main file. So let's go to main.py, and over here we will import some stuff from FastAPI, then FastAPI middleware course. Okay, then we will import the routers that we have created. So this is auth router, then there is health router, and now we will create the FastAPI instance. So FastAPI, in this define the title. So title is Oh, settings we have not imported. Let's import settings. So settings dot app name. Then here you can define version like 0.0.1. Then description you can define. The description you can define like this, anything whatever you want to add. Okay, now there is a same like express.js or any other thing, you can add middleware in the app. Oh sorry, why app? So add middleware. So in the middleware we will define course middleware, and then we will allow origins that we have defined in the env. Okay, so backend course env, and allow methods all, allow headers all, allow credential true. And here we have two routers that we have created, so there is a method include router that will be created, and here we will add logger dot. So let me import logger. So let's create an instance of logger from logging.get logger. Okay, and here at the end we will write like application startup configured, and extra information like app name, API prefix, LLM provider, or Elasticsearch index that we can pass. Okay, now save this, and now let's try to run our server. Okay, so open terminal, and what this stuff terminal is doing. Gosh, yeah, open terminal, then first of all activate it. You can see it is activated now. Now there is a command uvcon. So uvcon is basically used to serve the FastAPI server. Okay, that will open on the port. So if I search uvcon over here, you will see yeah, so you can see this is an ASGI web server for Python, so you can usually use that. So this is how you are defining your app, but as now we are using FastAPI, so FastAPI already created app for us, this app, and now we need to start this app using this uvcon. So the basically running is this simple uvcon and then your app name, then app. Okay, so in our case uvcon app, in this folder app. Okay, then we will go to the file main. Okay, over here main, and in this we have again a variable app, and then we want to reload it if there is any changes, and then we will define the host on which port or host you want to run. So I want to run on localhost, and here is the port I have defined, that is 8000. Okay, now hit enter, and yeah, you will see some errors. So these are some errors. No module named app. Okay. it's not able to recognize where is the app module. So let's just ask chat, this VS Code chat, what is the error? So basically there is this config.load app and then server. In the load app it will go to self.app. Um, okay, I got the error. What is the error? So basically it is not able to recognize this app module. So we need to define the init file that we are talking. Okay, so in the app we need to create .init file. So you can see there is option 1, run from backend, this backend, and then so where we are. Oh, sorry, we are in the Agentic AI. Oh, I'm extremely sorry, guys. Let me clear and again do run. Yeah. Now the error is saying what? Why it is taking as a different command? Cannot import name auth service from this. Then why? Let me check. It is in the auth service file. Okay, so there is a spelling mistake. So yeah, this is now also fixed. Yeah, you can see now server is started successfully. So there was a spelling mistake. So you can see this is how you can debug anything. Okay, whatever error you are getting, you don't need to go every time to the AI and ask. Otherwise, your brain will stop using. Okay, so yeah, so this is on the local host it is running, and here we can open one more terminal, cd frontend npm run dev, and let npm run dev, and let's check on the localhost 3000 what is the status. So here I can see, okay, let me open on this. So here you can see backend is online, Redis is online, okay, model is online also, provider is Hugging Face, but Elasticsearch is offline. Okay, so Elasticsearch we haven't configured, so let's configure that and let's try to register user. So we can enter any kind of email and let's check it in the logs. You can see we are getting this API calls like get health, get API, enter password, create and enter, and let's see, yes, this API is getting called and we are seeing the log over here. But this logs is not what we want. We can implement our own custom logger. So for that, in the app, let's create one file, logging dot config.py. So usually this file you can create for your custom logging. So here we are importing this stuff from Python itself. Okay, so JSON logging context vars, and UUID, date time, then rotating file handler, and then this typing. Okay, and here we will create here you can go to chat GPT and ask to create some random colors for the logging, or you can even ask for the file itself, it will create for you. So here is the class in which there are some colors for debug this type of colors. Okay, and then here we will define the log context. So in the context vars we are defining this log context. Okay, and now we will get the log. If you have set anything on the env, you can usually get those envs directly from over here. Okay, so here I have defined I will create a log file like a multi starter log, or I can create a backend.log. Okay, and even though I can mention over here the log path. So here there is a JSON formatter class we need to create. So this is a kind of a long file, lots of code, but it is very easy to understand that we are not doing any stuffs like that you don't understand. So here is a JSON formatter class in which there is a format function. So whatever logs we are getting from over here, these logs, okay, so we will be converting in a payload where there will be timestamp, agent type, agent is calling session ID, okay, route, etc. This kind of stuff, and we will be excluding these fields from the logs, and we will create a, I mean this JSON, this entire JSON will be dumping into serialized in a single string. Okay, then there will be a formatter for context. So we will be creating a class context formatter in which it will be formatted like this. So there is a format method that will format in a logging for logging, logging schema. And after that there is one more function if you want colored formatter. If you want to do a color format, then we will create one more class colored formatter in which there are these type of colors, and in the format we are defining whatever you want to color it. So this will be color timestamp, then colored label. Okay, then after that this will be combined together, and in the messages we will log this line as a colored log, and this is a record execute. If there is a record, then we will format the exception as well, and we will return the log line. And if you have applied any kind of context filter in the sense like if you just want to see session ID, or if you want to see transaction, okay, so this session ID, transaction ID is basically when you are operating on the LLM, so you will see what kind of session or transaction in the logs happening, okay, and which user is making calls. So we will be keeping all this context in a log context. So set log context, thread ID, agent type, user ID, route, this you will be passing, and you will see this set log context we will be using in the, and whenever you are making a call here we can write update log context. If you want to clear it, then you can clear it as well. and you can put this logs in a specific folder. So for that there is a create file handler and there is a make directory, and using rotating file handler we will go to this logs folder, and in this we will uh, keep storing the logs. Okay, and there is a backup count as well and maximum bytes. So if the size of the log file is beyond the maximum byte, then the backup will be created and new file will be created. So this file will handle those stuff. Then we will define here configure root logger. So we will be getting the get logger from the main logger that we are using, and in this we will set the level as get log level, and whatever we have created like context filter or whatever we have done, we will pass it to the add it to this uh, by default logger, and we will return it over here. Okay, so this is how you can see the logs will be formatted and this is the main line where we are exactly formatting it, and after it is formatted and it will be returned. And here we will be defining a uvcon logging function. Okay, so in this we are configuring the load logger. This entire methods will be called, and we are checking we are able to access the uvcon error or uvcon access or not. So if we are able to access all those things, there is no such errors, we will return true. Okay, and you can see there are this colon written every time. Okay, so this we will be removing using our logger dot remove handler, and you can see what wherever is this. So in this entire logs will be formatted and everything will be removed and you will see a new logs. So I don't want to waste my time on explaining this logging config. You can ask ChatGPT to explain you, but it is useful to see the logs, so that's why I have added in our project. So for that you need to basically import the file that we have created just now to app logging configure uv logging, and then we will call that method over here just above this logger. Okay, so once it is done, uh, you can see we are getting now custom logging. Okay, in which you can see like on from which file this logs is getting logged and if there is any error. So this is kind of a eye catching thing in the sense like you are easily able to understand. Okay, and there is also logs folder automatically created. In this logs folder, if there is any such logs, you can easily store it as your history, or you can send it to anyone for the review or anything like that. Okay, so these are the logging methods you can implement in your Python server. Now it's time for creating the Elasticsearch. So don't rush on completing this project. Okay, you all know like Python can do that in very less time for you, or Python or any AI IDE or tool can do in very less time for you. Your main major point or why you have come here is to understand stuff. Okay, your main goal is to understand stuff so that even if you are building your next project using any AI editor, you will easily able to debug and understand what uh, is doing. Okay, so Now go to services and let's create here search service. So services, create a file, search, then service.py. And one more thing you will notice here that there is a PyCache file automatically created. So this cache file is basically used for Python compiler, that it not every time go and interpret. So that basically make things faster for Python to execute if you are not making any changes. So but these files should not be uploaded on GitHub. It is operating is version is specific, so you need to basically exclude them. So here you can say you can exclude PyCache. You need to exclude .pyc file, .env, pytest cache, dist, build or logs folder. Okay, this kind of thing you need to ignore it. Now we are on the search service. So on the search service, let's import some stuffs from first of all. So we are importing search result from the chat models, and here we need to create the search service class in which we are defining the Elasticsearch URL, Elasticsearch index, API key, and the same what we have done for Redis. And let's import lib that will use for importing the module over here. So try import lib, and here we will import the Elasticsearch. So that is also imported. Okay, and from get attribute we are getting the Elasticsearch module with the name. Now there is a check, like there are some users that may store Elasticsearch on a different virtual machine, or maybe you host your Elasticsearch somewhere else. So you will be passing the Elasticsearch URL, not your local Elasticsearch. So that's why we can create a connection parameters if you are providing any URL. Okay, so by the way, we are providing the local URL over here, but in that case, if there is a cloud URL, if you have, okay. So if there is a API key, if you want to add, you can add for the authentication, but if you don't want, this authentication will work that we have added. Okay, and then this client will be, you need to call Elasticsearch with this connection params, and then after that we will test the connections using info. So in this you will see initialize or not, and if there is any exception. Okay, so if there is any exception in the try, you can see we are in the try block, and now we are in the exception, then we will throw the error and we'll set the client as none. Okay, now let's define function to ensure index. Okay, and now the important part has come, that is ensuring an index. So before that I would like to explain what is indexing. So indexing, you can say, is like organizing data for fast searching. Okay, so let's say you have a book, and in your book, let's say I tell you to find where is a Python chapter. So you will go one by one each page and see where is Python. But if you directly check the index page, the first page of the book where everything is written, like Python chapter is on the page 42 or anything like that, so you can directly jump to that, you can directly look up to that page. So same happens over here in Elasticsearch. So whatever data you feed under Elasticsearch, it will break into a like it will break into a textual format where it index everything. Okay, and that index it will provide us a quick result whatever you want to search. So it is like a search engine. So Elasticsearch is like a search engine database optimized for your full text search. Okay, and you can think of it as a Google for your application data. So yeah, that is one of the thing that it does. So here I will create one function, ensure index. Okay, so what it does, it creates a container called an index, like a database table, and in which we are defining fields, analyze for full text, and a keyword is stored as is for exact matching and filtering. Okay, so if the client is not initialized, then we are doing. If it is exist, then we are creating a container with this indices. Okay, title is snippet, category, and source. So these are how you can index. And now it's time for doing the bulk index document. So when you call the API to ingest all the documents or do the bulk indexing, how it will do, we will create one more function, bulk index document, in which you will provide the documents in the sense list, dictionary, or any type. If it is not running, there is a error, not available, and then we will say if Elasticsearch is available, bulk index is started. Okay, then first of all we will call this ensure index. So our first container has been created or not. If it is created, that's good. Now we will do the operations. So every document we will first of all convert in this JSON format, so using this list append method. Okay, so here we are keep on creating index, and here we are keep on adding document directly, and we will be calling this Elasticsearch bulk, in which we need to pass operations as in this format, and then refresh. It will be automatically refresh after bulking, and this is something like how much it is bulk or the logging basically. Okay, so this is the bulk index document, and now the most important, the search. Okay, so search method is used in the search agent. So what it will do, you will ask any query like what is Langfuse, what is Langchain. So this whatever you have asked, it will go to the search function and call the Elasticsearch function. Okay, so from here you can see this is a search function in which you are passing your query, and it will return the list of search result. Okay, now these are the initial checks and logging stuff. So here is the main part in which you are calling the Elasticsearch search method, and here is the index name you will be passing. Okay, in which you have indexed all the documents earlier, and here is the query that you are passing, so in which we are applying the multi-match on the title, snippet, and category, and the size will be 5. So I need 5 result. Okay, so whatever hits is basically wherever he find that keyword, it will return us, and it will return in the you can say an array. In array there will be title, snippet, score in each element. Okay, and this also provided by the Elasticsearch itself, so we don't need to worry about. And here you see this is a very compact Python syntax in which we are first running the loop. Okay, in every loop, every hit, we are converting data into this format, and after converting the data into this format, we are creating an array of items, and that is going to be sent. So yeah, this is what Python power. You in a very small syntax, you are doing lots of stuff, and this is basically an exception. So okay, and one more property we will add over here available. So this is used for checking health checks. Okay, so yeah, so yeah, we are almost done with this search service.py. So there is no any errors, you already have code. The main point is to make you understand what we are doing in the search service. And yeah, obviously you need to understand Python syntax. So some prerequisite is needed. Okay, but still, if you have understanding of any language, you can understand Python code very easily. Now I will go to health router. So health router, apply here, import search service and Elasticsearch connectivity. I will send this. So this is these basically used in the front end code. Okay, so in the front end code, this API is getting called health, and that will basically give us which are online, which are not online. Okay, and let's create the search service instance. So that is a class, we cannot directly access it. Saving it. There is no such errors. You can see it will automatically restart or okay whenever you make any changes. So if I reload it, you will see Elastic is online now. Okay, so all the services are online. It's just that we need to implement the chat feature. So the main the reason why you are here, it's time to implement. So all the Redis, all the Elasticsearch, logging, okay, this kind of stuff, we are done with it. Now let's start. So on the this, first of all, you need to ingest the data. Gmail.com, sorry. So here we will need to ingest the data, and if I inspect and go to network, when I click ingest data, it is calling the sample data API, and let's see if it is. So you see there is a API, we will ingest sample data. So let's create, go to routers, create here ingest router.py file, and in this file, so here in the dependency, let's create one file, auth dependencies. Okay, why we are creating this file? Because the data ingestion is very crucial part, and that cannot, any user can do that. So right now we are not implementing any such checks, but if you want, okay, if you want, you can implement a specific email, like only this email can ingest data. Okay, so this is how your auth dependency will look like. Let me show you. In this, we are importing the header HTTP exception from FastAPI, then these services, then creating the instance of this services. Then there is a method we are defining, get current user, in which there is a authorization with header default, and we will be returning response. So you must have a token to make this API call first of all, and in this we are extracting the token, okay, using this replace the basic string manipulation stuff. Then we are decoding this token and we are verifying, okay. And in this one, if there is no email, then we are throwing error, token subject is missing. If user is there, then we are getting the email from the token, okay. And then user is not found, then we are saying user is not found. If the user is found, then we are returning this, okay. So this is kind of a middleware, you can say. Then ingest router, we will be having one more thing. So in the data ingest, let's create a file csv ingest. So here one more thing, data can be anything, okay. Data can be your SQL data can be your MongoDB data can be your there can be multiple PDFs that you want to ingest, okay. So it can be anything based on your needs, but but here we are implementing CSV ingesting, okay. Why? Because we have this CSV data. If you want to ingest PDF, then you have to implement PDFIngest.py, okay. So you have seen AI resumer website kind of stuff. So what they does basically, they first, when you upload your PDF, they will ingest all the data in the Elasticsearch or VectorDB, and it will then after processed by AI and Elasticsearch to get what you have in your resume. Okay, so CSV ingest is kind of very simple. You need to import CSV module, and then you need to pass the file path, and the file path we will be defining in the ingest router. And csv.dictionary read, it will read the CSV file, and then there is a array of this reader in which we will be going to append the document in this format. Okay, so this is it. Now go to ingest router.py file, and let's create a method over here. So here you can see we have imported all the things. We are creating instances. Then here is the API call router post ingest sample data. In this response model we may ingest response. So how we are inserting it, you can see we are first of all loading the documents from this AI tooling catalog.csv file. You can see here somewhere we have data. Yeah, this file. Okay, and after that we are ingesting it, and we are calling this bulk index document from the search service, and it will be all indexed, and then we are returning the response. So yeah, this is the stuff for data ingestion we are doing, and I hope it is restarted so we can go to front end. I will refresh it once again, and I will now call this API ingest data. So here we are getting detail not found. Let me restart again. Okay, sorry. In the main.py, I guess we have not registered. So here it will be ingest router, then app.include ingest router. That's it. Let's restart. You don't need to restart, by the way, it will automatically restart, but still I sometimes restart to be sure. Now ingest data. You can see in index 10 data, and the API got completed. If I close this inspect, you can see in the events and logs like post ingest, this API is getting called ingest completed. Okay, so all the data is ingested now, and if I go to this Elasticsearch container, I will refresh once again. So here you will not see inside what is happening currently, but yeah, data ingestion is done on this one. Indices rolled over. Okay, so yeah, data is there in the ingestion, I mean in the Elasticsearch. Now if we want to search like explain Redis caching, it won't do anything because we have not implemented the chat. So let me close this, and yeah, let's quickly understand first of all some Langchain basics, like what is edges, what is nodes, what is state, graph state. Okay, so these kind of stuff. So let's go. From here we are actually starting Agentic AI. Okay, so all the part what we have done so far, like till now, is just FastAPI or backend server stuff. But now we are going to develop Agentic AI, and before directly jumping into, I would like to cover some theory so you will get an idea. Okay, so first of all, the tool that we are using in Agentic AI development is Langchain. Okay, so before Langchain, you guys might have know, like, first of all, there is a prompt AI comes where we use open API SDKs, or any Llama SDKs to directly make API calls. Then we do prompt engineering to tell that LLM to do a specific task. And after that, there is a generative AI comes up. Okay, so in the generative AI, we are basically defining and generating models query, and based on that, we are getting the response. But now we are in the agentic AI era. So in this agentic AI era, you are using large language model as an agent. Okay, you can build things um, like like you can build an entire IT team with it. Okay, you can schedule your entire work management, even though you can also build your custom developer, AI developer. Okay, so instead of you working there, there will be lots of agents working for you, and they will asking if there is anything permission needed. Okay, so these kind of capabilities can be reached by using agentic AI, and that is what currently companies and all the available tech giants are expecting. So Langchain is the tool that basically you can use it for working with the large language model, that what I have written over here. Okay, so what it means by that, can we not work without Langchain? So the answer is yes, obviously you can work, but Langchain provides you lots of stuff that makes our task easier. Otherwise, you need to define everything what is inside in Langchain to build agentic AI. But with Langchain, you don't worry about API details. In the sense, Open API work different, Cloud AI works different. There are other API details. Okay, but Langchain gives you everything built in. You don't need to worry about what is the API call parameter or data. Okay, you are just using a singleton pattern, I mean single method from the Langchain, and it can be sent to any AI models. So that is the power of Langchain, and it gives you flexibility switch between different LLM providers. So what I have said right now, like you can work with any LLM model, and even though you can switch to any LLM providers easily. Okay, so also you will get composability. Composability means combine components to build complex workflows. So this is the thing like Langchain provides you. It provides you a chaining in the sense you define how the workflow will be going. It will be going from agent 1 to agent 2, agent 3, like that. So you can do with Langchain. And also Langchain gives you memory, that is built in conversation history management. So Langchain has checkpoint or human in the loop features. Okay, so that thing we will going to cover in next video, but in this we will be using this tool. Okay, so there are lots of stuff in Langchain and Langgraph itself, so we can't cover in this video. But yeah, first you build this project, and in this project only we will uh, develop other steps and go beyond what we have developed right now. Okay, so this is why Langchain is needed, and Langchain provides us, and Langgraph is enables you to create complex stateful workflows with multiple agents. Okay, so here you can see there is a stateful word. A stateful word means there are multiple agents. Okay, every agent will have, okay, so there is, consider there is a data. Okay, you are passing that data to agent 1, and agent 1 will pass and do some modification, and then send to agent 2, and then send to agent 3. So how you will be sending this data? You will be keep on passing variables. So that is not a good approach. With Langgraph, you will get a graph state. With the graph state, you can create a single workflow state that will be shared among all the agents, and they can easily or parallelly manipulate it. Okay, manipulate or modify it. And now if you want to understand what is the difference between Langchain and Langgraph, so Langgraph is actually built top on Langchain. Okay, If you are installing Langchain only, then Langgraph is not needed. But if you are installing Langgraph, then Langchain will be also getting installed. Okay, because Langgraph is built on top of Langchain, and you can, if you want a real world example, you can see this is a Lego building blocks. So Langchain you can consider as a Lego building blocks where you can creating an architecture, then you are using Langchain. But with Langgraph, what you are doing, this is a kind of a blueprint. So if you are working with a very big architecture of Agentic AI, then Langgraph provides you a blueprint, or using this you can develop a very complex architecture, or not architecture, I mean the AI workflows with multiple agents. Okay, so this is basically your Langchain and this is your Langgraph. Now here is an example. So let's say when you make a API call, it will go to agent 1, and then agent 1 is deciding which agent to route. So these kind of complex workflows can be done using Langgraph. Okay, now I will like to explain some keywords that we are going to use in Agentic AI. So state is the data that flows through your graph. It's like a shared memory that all nodes can read from and write to. Okay, so what I have explained you, that is stateful workflows. So this is what state exactly in Langgraph, and state is mutable, nodes can modify it. And here nodes basically means individual steps in your workflow. It can be agent, it can be any specific task. Okay, and this state is persist, it carries information between nodes. So nodes to node the state will be passed. Okay, and state is shared means all nodes see the same state. So if there are 2 agents or 3 agents, they all will be having access to the same state. Okay, now if we talk about nodes, so nodes are individual steps in your workflow. It receives the current state, this basically this above state, and performs some action. You can call LLM, you can call search database, or you can query something, or even you can research on internet. Okay, so there are multiple things or tools or anything you can develop with the nodes. And if you are using nodes, it can update the state also, and after updating the state, it will return the modified state. Okay, so this is, you can see how graph state will look like. So here you can see we have this state that is initially empty. Okay, and user have asked what is Langchain, conversation ID is generated, other things are blank, and route 1 is summary. Okay, so supervisor node will read the state, it will update the route to summary. So route is updated, and the summary node will again read the state, it will update the summary output. So here you can see summary output will be updated, then final node will again read the state, and the final answer will be updated. Okay, so this is how you can see every node had modified the state. If there is one more agent like search engine, or there is parallel execution, so accordingly this state will be modified by those nodes. Okay, so this is basically nodes. And if we talk about edges, this is one of the important thing in Langgraph. Edges connect nodes and define the flow of execution. Okay, so there are normal edges, like you define from supervisor node, like if someone is asking for a, let's say if someone is saying hello, what is the weather today, so this will go a general question. So this will be getting added as a edge on the node A to node B, and it is a sequential execution. Sequential execution in the sense, first you will get a weather from the node A, and once you receive the weather, it will be sent to the again supervisor agent, and supervisor agent will answer to the user. Okay, so this is how basically node 1 node B you can do, and this is normal edges. This is not conditional, but there are some conditional edges as well, so in which you give supervisor to decide which node or which agent he needs to use. Okay, so if there is some data that is related to image extraction or image from image to text, So that will send to the agent that is defined to do that task. Okay, and if there is a agent that is defined to search something in your database, so accordingly whatever is your prompt, supervisor will make decision on that and then call the nodes. Okay, so this is how basically it works. So these are basically some terminology that you should be knowing. And after that, what we have developed, let's see the complete flow. So let's say we have asked what are the best AI tools for data analysis. So first of all, the workflow will run. It will create a conversation ID. We will check the cache is missed or not. Okay. Then there will be initialization for a graph state. Now supervisor agent will decide the route. So here it analyzes AI tools data analysis. So decision parallel. Use both agents. Why? Because we need to gather the information as well. So here you can see it will make a call to search agent. It will query all the documents and stuff, whatever is available, and it will call the summary agent to then get the text what user is searching. And after that, it will be sent to the LLM, and LLM will now, based on these two agent context, it will generate a final answer, and that will be stored in Redis, and this will be returned to the user. So this is what we are developing. And in this there is one more flow, like it can go search agent, then summary agent, then combine result. It can go directly to summary agent if there is nothing you are searching. Okay, and it cannot go sometimes it cannot go to summary agent if you are simply asking like find details about Langchain. So it will go to search engine and then it will answer. Okay, so there are three execution that can happen based on supervisor is deciding, and this supervisor dot decide route will be defined by us. Okay, so yeah, this is basically a simple terminology that you should know. And yeah, let's start building. So apart from that, agent, I think you already understood. Agent is like a specific node. So let's say summary agent is basically specified in summarizing any kind of textual data. Okay, and search agent specialty is to search something in the database. So this is what basically agent means. And multiple agents orchestration means we are managing based on their needs. Okay, so supervisor agent will manage them. And apart from that, there is a multi-model multi-agent system. So multi-model in the sense, for query extraction we will be using a different model, for image extraction we will be using different model. Okay, so these kind of different models when we are using for different approach, that will call as a multi-model agent approach. Okay, and there are some, if you work in a very big project, there are some fallback model as well. If let's say there is a timeout, or if there is some error on an agent, then it will fall back to another agent, and then it will again make a call, and then we will receive response from it. So yeah, this is what currently that you are seeing in companies they are developing. Okay, so here I would like to start with a state. Why state? Because firstly we will define how our state will look like. So here let's create a file, graph state.py. Okay, and now I am going to write each line one by line so that you will understood everything. So here what we are doing, we are importing data class. So there is a data class is lib, in from which we are importing data class and a field. Okay, and now we are using typing and importing some types like dictionary, list, and optional. Okay, and now we are importing here models.chat models for the messages, chat message and search result. And now let's create a data class graph state. So this is decorator. Basically this decorator will make our classes state. So you can see there are these state. So every type and validation will be done by this data classes. So it will be class graph state, Oh, what? And here we will be defining some fields like conversation ID, user messages. Okay, so there is conversation ID, user message, history. Okay, the previous chat that we have having with AI and conversation context, then route which uh, agent to route first, then summary, output search result. So that we have defined over here. Okay, using graph state. And here it is not necessary to use data classes. Okay, you can use pydantic model as well, but we are using just to make the data validation will be clearly and correctly going for all the LLMs. Okay, and it will be remain singleton, so that is why. Now here what we will do, we will go to the agents now, and let's create our first agent, that is uh, search agent. Okay, so here search agent we will import graph state and the auth service, then chat models, agent result settings, the envs basically. And now what we are doing, if settings dot langfuse, so the langfuse configuration that we have added over here, you see. And I think Langfish is also waiting for first trace. Okay, it is keep on waiting over here. So what we need to do, whenever you want, so this agent is like a node. Okay, and we want to trace this agent, what parameters he is receiving, what response is output is going on to the next node. So this kind of tracing we are checking is Langfuse is enabled or not. If it is enabled, what we will do, we will try and import Langfuse, import observe from it. And here you can see we are not importing Langfuse at the top. Why? Because let's say if you have already disabled Langfuse, then if you are importing it, then it can improve some, degrade the performance. So this kind of approach Python provides us, and this is what is the power of Python, I feel, because it runs line by line and it is interpreted. So yeah, this kind of basic stuff you already know. So in the observe, okay, we will add arguments, then there will be keyword arguments, so kw arguments. Okay, and in this one we will define a decorator. There will be a function. Now we will return this function, and here we will return decorator if arguments and callable arguments are 0. Okay, as decorator. So here what it means by this line, basically we are trying to observe whatever arguments is coming under API calls to the search agent. Okay, so whatever is happening under search agent, we are observing it using this function, and if there are any arguments, we are calling with the arguments. Okay, otherwise we are simply returning the decorator. So this is one of the thing, that is when Langfuse is enabled, and when Langfuse is not enabled, we are also doing the same stuff. Okay, so why we have written this 2 times, because this is basically in the Langfuse. If there is anything in the import is missing, then only, but this is something for the else case when Langfuse is disabled. Okay, Now logger, let's implement logging dot get logger. And also like there are some parts, like these kind of parts, you don't need to like go much deeper in that, but if you want you can just copy this code snippet and go to chat gpt to understand. Okay, basically these are boil snippet code that you get from the Langfuse documentation itself, so there is no need to worry. Okay, search agent will be there. Now here we will initialize a constructor self search service. Okay, and self dot search service and here we will use this decorator observe that we have defined above, this one. So now it is wrapping the entire search agent. So here we will give it a name, search agent. So whatever you are giving the name over here, that will be seen on your Langfuse. And this is a async function because it can take time. So, and we will be passing graph state in it, and it will output agent result. Okay, now let's implement logger, in which we are saying like search agent is started. After that we will be doing the search service and we will call it. So these search services we have already defined. So if I click, you can see these things we have already defined. Okay, so this is search service, then state dot search result, that is coming from the graph state. We will update it. So we are updating it, and in the lines we can create an array. Okay, so in the array we will be defining like what we have found in the search. So there will be index. Okay, and in the all index we will be outputting the title and the text. So here we will be using f string. You can easily write variables in it. So here a score will be item dot score, and these things are basically provided by Elasticsearch itself, that what we are using over here. Okay, and now this is basically a floating value to make this score 2 decimal. Okay, now I will be writing here item dot snippet. So every response we will be doing this, and now run the loop. So loop will be running for index item n, and to make this result as iterator you can use enumerate to make it iteratable. Okay, you can see it is returning a enumerate object, so that is why we are doing it. And this is kind of a short syntax. Even if you didn't get it, please go to chat gpt and it will give you a little 4 to 5 lines of expression, then you will understand easily. Okay, and in the output we will be saying search results from Elasticsearch is new line, and we will be joining this with the lines that we are having. Okay, so this is how basically we are formatting, and now in the search output we will save this. So in the search output we are saving this, that is saved now. Now again we will be we can log this for our logs, and now after this we need to return from this function. Okay, so we will be returning agent result, and this agent result, there will be agent is search, then output is output simply. Metadata we can send like result count. And in Python, if you want to find the length of a array, you can simply use len results and index name. Not just array, you can use for a string as well. So search service dot index name. Yeah, so this is your search agent, or we have successfully created our first node. Let's save it. Now let's create one more agent, that is summary agent.py. So in this one also we are doing the same thing, just copy from what we have in the search agent. Okay, it's just that we will change this to LLM service. So this we are going to create. Why? Because summarization we will be doing using LLM. Okay, so in the services we will create a file LLM service.py. Okay, basically py. So this LLM service quite we need to build. So first of all import logging, then typing, and here we are importing OpenAPI. Okay, from OpenAPI SDK we are importing OpenAPI, and now here we are importing app.config.settings, import settings. Okay, and the same thing we will be doing over here as well for the this Langfuse enablement. So just copy this, go to LLM service, paste it, because we want to observe this LLM service, like what LLM is sending, how many tokens are getting passed. So these kind of observe and tracing we can do that. Here we will create model capability. This is just a enum. So in this, with 3 triple dots, you can write a comment. Okay, that is not executed for your code, but you can see and other people can understand. So here we are defining the capabilities for different models. So for summarization for code generation, the reasoning. So this is basically enum class we have created. Now let's define model configuration. Model config. So from the Hugging Face we are using 4 models. So we will define one by one for each of them. Okay, so models, and this will be an dictionary DeepSeek AI. So this name what we have added already. So DeepSeek version v4 Pro. Okay, now here capabilities, maximum token that you want to pass, and how much size you need it. Okay, so all this stuff you can define in the model capabilities. So this capability is basically if there is something reasoning, this model will be getting used. If there is something summarization, this model will be getting used. Maximum tokens means this whatever user type. So basically one single character is a token. Okay, so how many tokens you can send to this user. So this is what is defined, and temperature. These are some model configuration that you can add. Okay, and this is best for summarization, and size is this. Okay, and this all information you can get from the Hugging Face itself. I mean this information, and this information. Okay, maximum token you can increase based on your need, but yeah, that is fine. And now here there is one more model, Quen, for the coding you can use, and there is Meta Llama model that we are using for question answering. Then there is one more Meta Llama model for general purpose and task. Okay, so here we have defined all these models, and you might be thinking, bro, we are not using aggressively in this project, so I just wanted to tell you this project is not just end in this video. In the next coming video, we will be improving a lot in this project. Okay, improving in this is adding more features, more agentic AI stuff. So that's why this kind of a boilerplate. Now it's time for create the class LLM service. So LLM service is using Hugging Face router and Open API capability, uses 4 specialized model for different tasks. Okay, let's define the constructor. So here we will define the client first of all. Initially it will be none and initialize client. Okay, now in the initialize client function we will be uh, this is a comment, basically we are initializing it. And now when we are initializing this Open API SDK, if settings.hugging-face API key not configured, then we will return. There is no need to configure because it will throw an error. Okay, if this Open API is available, then we will use this base URL that we get from Hugging Face, and this is the API key that we have set. Okay, and if Langfuse enabled, we will log like tracing is enabled from Langfuse. Now now it's time for the get model capabilities. Okay, so for that we will create one more function, get model for capabilities, in which you will be passing model capability. Okay, and select the best model for given capability. So let's say if you are doing code generation, then code generation will be picked up. If you are doing anything else, then that will be picked up, whatever we have defined. So this is a capability model dictionary, in which summarization we will be using this, code generation we will be using this, and this settings dot is basically what we have defined in the environment variable. Okay, and now custom model. So we will get the capability what we need to use. Now this model we are going to use for LLM service, and these are the default models. Okay, so model default models dot get capability, otherwise this default one. Okay, and now we are mentioning over here for this specific capability we are using this model. Okay, and we are returning it as well. Now the main function is coming, so let's add an observe on it, give it a name of this node, LLM generate. So this is used for Langfuse for tracing. Okay, this part observe is at Langfuse part. Now create a function generate. So in this generate it will output a string. Okay, and in this generate let's pass this self to access the class things, then prompt string model. Okay, maximum tokens, temperature, capability. So all this stuff will be there. Now we will in this one define what this LLM generate will do. So let's add a comment. So generate text using Hugging Face router. Okay, in which we are passing this argument, and it will generate the return just generated text. So this is just for our documentation, or if we are calling this function we can see the docs like this. Okay, and now if client is not there, then we will raise an error like Hugging Face router client is not initialized, and the model is not there, then we will choose by default model if you have don't set up in the in the environment. So that what we are doing here. Elif means else if. Okay, in the Python, and logger.info, let's add a log here, like we are generating with Hugging Face router, and this is the model that we are using. This is the temperature and maximum token. Okay, and now here let's call the API. So do one thing, use a try catch. In the try, let's mention create a variable completion self dot client dot chat dot completion dot create. Okay, so these are all the coming from the open api sdk, so you can easily understand. Okay, and in this one we will be passing all these things, messages, the user prompts, maximum token temperature, etc. And once we receive the response, we will log the character. Okay, the received response, and it will be under completion dot choices message dot content. Okay, and now after this let's write except if there is any error. So exception as e, give it a alias, and simply log and raise. Okay, simply log and raise, it will raise the error. So the same way what we have done for generate, we will do the same for summarize. Okay, so let's create a function async def summarize self text str context. If you are not providing, it will be empty, otherwise we will be getting any error. So summarize text using DeepSeek this v4. Now there will be a prompt we will be doing. So prompt we are adding to LLM is summarize the following text concisely. Okay, and or we can do one more thing. Instead of writing prompt over here, let's create a prompt folder, so that will be much easier, right? So do one thing, here in the app let's create one more folder, prompts. Okay, so in any app there are lots of prompts, so basically telling the agent that, hey agent, your work is this. Okay, and now in this prompts we will define dot llm prompts from llm prompts, and these are all the imports. Okay, and let's create a file over here, llm prompts prompts.py. So there is gone. Now in the llm prompts.py, what we can do, we will centralize prompt template over here for llm operation, import dictionary. Now create a class, so these prompts are basically you can generate using chat gpt or anything, but let me write for you. Okay, so here is the basically documentation what this is. So this is a collection of prompt table. Okay, so in which you will define all the prompts. So first static method we can add in this class, and the method is summarization. Okay, so in this summarization what we will be doing it, we will be returning f a string, and whatever we are writing over there we can write over here as well. Now here so this This we can write like summarize, and then we will pass the context to summarize the LLM. So whatever we are receiving, that will be a context. Then here text to summarize. Okay, then here it will be the text. And how agent will output like this. It will output summary and so on. So here this is getting closed. Okay, the same way we can add other methods like for code generation. Okay, for question answering, like that we can add. So let me add that for you. So there is one more method for code generation, so that is also added over here. Okay, yeah, we can remove this. Yeah, so this is a static method for it. Now we can add one more for question answering, simple question and answer. So let's add that as well. This is a static method for question answering, in which we are prompting like answer the following in this format. Okay, and if there is something related to reasoning, we will be doing the same thing. So for the reasoning, you will be giving the problem and it will be providing you a solution. So what are the static methods in Python that can be directly called without instantiating the class? Okay, so or let me check. And there will be chat summary. So this chat summary is one critical one, in which user will be prompted. So there will be some conversational history, and you will be AI assistant and user will be responded. Okay, so yeah, these are the stuffs. Then if there is a get all templates function, so that we can define over here. Okay, and then a static method. So a static method like is just for formatting, like let's say your argument is template is string for this placeholders, and then this template. And don't be confused about this. This is just a documentation part kind of thing. This is not related to code or affect anything on that. Okay, and this will format our custom prompt that we are having. So let's save this LLM prompts, in which there are some static methods. Now go to LLM service, and instead of using like this over here, um, we can summarize. So here we will be importing LLM prompts. Why it is not imported? So LLM prompts, let's import at the top. Okay, now you can see we are summarizing, or we are creating a prompt based on whatever we need. Okay, and after that we will call this generate function. So generate function is used for API call. So this same thing we are doing for summarize, we are same doing for the 4 other calls, like generate code, answer question, okay, list available or not. So whatever we have done for the prompting, the same thing we will be repeating again. So you can see I have added this generate code, in this we are using this, and the prompt will be getting, and we are calling the same function again and again. Okay, and you might be thinking, why are we repeating this thing? The reason is there are some cases where you need to explicitly change some stuff for a specific model, so or a specific kind of prompting. Okay, so in that case it is very easy to manage in a different function, otherwise things will be messed up. So yeah, this is your LLM service right now. Now if we go to summary agent, we are already importing it. So summary agent, let's create a class over here. Okay, summary agent class, LLM service. Now we are observing it and we will run this, and in this we will call the LLM service function. That is basically simply this summarize. Okay, so summary agent observe we have added for Langfuse, and this is running. We are getting the graph state. Agent data will be returned. This is a logger that we have added, like what is the context message preview. Okay, and this is a summary, like LLM service dot summarize user message and the conversation context earlier what we are having. And now here is the summary output we will be getting. Then we are logging it as well and returning in the agent result. So this is how your summary agent is completed. Okay, so summary agent is quite long because we are dealing with lots of other stuff with that. Now final agent is supervisor agent, which will be routing two agents based on the needs. So do same stuff over here, import Langfuse stuff. This stuff we can do somewhere, like for globally, so we don't need to do every time. Let me check if I can do. So let's do one thing. In the decorators we can create a file .py. Okay, and in this decorator let's import logger and callable from the typing. Now here we will be initializing it, that what we are doing other part. Okay, and after that let's create observe function, and in this observe function we will be creating the decorators also. So there are wrappers we need to create. Okay, so here in the supervisor agent what we will be doing, we will be creating a supervisor agent class. Okay, which will decide the route. And now after that there is simple thing we can do is define a function decide route. Okay, which will output a string, return a string. Now whatever is the message, let's make it lower first of all, so there is no confusion in that. So user prompt will be in a lower case. Then here what we are doing, we are doing using search only keyword. So let's say in your prompt, if you enter search for, if you enter find documents or something like this, if there is such keywords, then it will go for the search agent. And if there is keywords like when you are greeting, okay, so greeting in the sense hello, hi, or something you are doing it, then it will go to greeting keyword. So here you can see we are making decision based on the keywords. Okay, so here are simple else if check, like if these words are in search or if something, and it will go to both in parallel, search and summary both agent. When you are not asking for search, when you are trying to explain, then it will first search to the database, then it will respond. Okay, So this is a logger info, then return route. So we are done with supervisor agent. Now it's time for creating the workflow for this agents that we have created. So in the workflows folder, okay, create a file, new file, chat underscore workflow.py. So under this chat workflow.py, we will do lots of stuff. So first of all, import all the agents, okay, all the Redis memory, LLM service, search service, graph state, logging info, update, clear log context, update log context, search summary supervisor, okay, UUID logging, async IO for async IO operation, okay, then cast for typecasting. Then there is agent result, chat request, chat response. So these things we will be using. Now the Langfuse part we are doing in wherever we are observing it. Okay. Now we create class, and after that in the initializer or the constructor, we will assign or we will instantiate everything whatever we have right now. Okay. So summary, agent, memory, cache, LLM, everything. Now we will observe and give it a name, chat workflow, and in this let's create function, okay, a run function. So whenever this workflow dot run will start, we will be having a conversation ID. So if there is already a conversation ID, that will be used. If not, then we will generate a UUID, and we will set the log context in the logging. This is the logging part. Then we will find out the cache key. If in the Redis there is already a conversation ID, then we will uh, store the key in this cache key, and if there is already answer, then we will use a cached answer. So let's say you already asked what is Langchain, okay, and then again you are asking what is Langchain. So we won't be making again API calls. So this is how you will be reducing your work. Okay, now stored context will be like if there is already position history, and here we will just log like chat workflow is started. So if there is already a cached answer, like what I have already told you, like if you already ask what is Langchain and again you are asking the same question, so same response will be sent to the user. Okay, we are not making a LLM to save our LLM cost. Now the conversation context will be storing everything, so you need to store the context, conversation context, message dot model dump, basically serialize it, and for every request dot history we are doing this serialization. Okay, or if there is already a stored context, we are directly using it. And now this conversation context we will be passing to the LLM, and let's append this conversation ID and message that we have just received in this call, in this run. Okay, now we will update the graph state initially. So conversation ID, user message history, conversation context, this will be updated. Now it's time for workflow to decide the route. So workflow means like how, like when we started learning DSA, I have explained you workflow diagram. So the same way we are defining, like first we will be doing these stuffs. Then we will be designing the route, and after once it is routed, then we will update the log context. Okay, then we will say workflow route resolved, and after that once we will create a list of agent result, and in this I know we can make a API call, but I have added this a constant for the greeting reply. We are not going to make an LLM call just for this hi and hello. So this is how we will save some cost of our LLM. Otherwise, if user keep on saying hey hi, then like it will be too much. So if this is greeting, then we are doing this, okay. And if it is summary, then we are handling summary. Then we are calling the agent summary agent dot run. Then we are updating the final answer, and these are the something errors, okay, like LLM not available or whatever is there. Now here one more like search. Then we will be doing for last part, in which we will be having the parallel answer. So this parallel one will be quite complex, not complex, but I can say too much process what we are defining simultaneously. So in the else if, okay, state route is search, we are just calling the search agent and we are updating the final output, okay. If it is not search, it is not summary, it is not greeting, then we will be going for the summary result and search result, okay. In which what we are doing, if summary agent dot run state, self search agent dot run state, okay. So we are making calls parallelly to both. Then result will be stored in search and summary. We will be checking if there is an instance of summary result. If it is an instance of summary result, then there will be exception, okay. Else we will be storing summary result and we are casting the agent result into summary result. So whatever we are having in the summary result, we are typecasting to agent result and we are appending in the graph state. And same we are doing for the search as well. And now final answer will become combined answer, then this output and how to read, okay. So this is what we are outputting to the user. And now it's time for updating the Redis. So we can simply update the Redis like this: self dot memory service append id and final answer, then cache, and we will log like chat workflow is completed, okay. And then we will say here this is the chat response, and we will return the response to the user, and this is the final response that the user will see on the screen, okay. So you can see this chat response is coming from the chat models, and this will be written, this response will be written, okay. So on the front end now this will be getting used, okay. Sir, we are done with the workflow and all that. Let's save it, yeah. Okay, so in this one we are mainly focusing on this workflow, like how we are defining the agent, the state management, all the workflow is done on this file only. So this is one of the very important files, so always cautious if you are making any changes into this file. Now let's create a router. So chat router.py, in this one we are making API call. So let's import this stuffs, okay. Chat workflow, we are creating the class instance and memory, okay. Then API router, is all the stuff you already know. And we will be creating first API, that post chat. So in this we will be returning whatever we are getting response on the workflow.run, okay. Now there is one more, if you want to get the context. So if you have already your chat up and there, then you can call this API, in which we will be going to Redis and find the messages, and then we will return to the user, okay. And there is one more, if you want to it. I don't think I have implemented this in the front end, but if you want, you can call these APIs to get things from the Redis, okay. And this is for clearing the message routing. Let's go to prompts and add one more prompt there, routing decision, okay. Why we are adding prompts over here? Because these prompts we can directly use anywhere else. So in this prompt what we have written, and these prompts you can generate using any AI editor or chat GPT. Okay, so I have given the context like uh, there this is to come, let me remove this is the main part. You are routing, it analyze this, handle the request and available routes as well. So if there's something related to this, if there is something related to search, if there is, so I have explained this thing to agent. Now he will decide, I mean LLM will decide which route to route. Okay. So LLM will take the decision, not we um, not taken by this keyword. Okay, so what we do is we can do one thing, we can make it a function, keyword based routing. Okay, and here we will create based routing. So in the LLM based routing we will use questioning answering. Okay, because that is more crucial and performance for question answer. Okay, we will use we will only need one word, so max token is 10, low temperature for consistent route. Now here let's import LLM prompts adopt and put LM service and capabilities. Okay, now this is, so you can see this is taken by this decision taken by the LLM and then use that route. Okay, and in this one LLM based routing and keyword based routing. Why there is a message error? This message dot strip message is coming, bro, over here. Why this is written 2 times? Now we can create the decide route, and in this decide route you can see basically we are deciding based on the LLM. If LLM routing we are using, then it will go to LLM, and otherwise we will fall back to the keyword based routing. Okay, here correct the indentation. The self, let's define this one. In the self let's create a constructor for the supervisor agent. Okay, so in the constructor we will define optional, so LLM service will be passed, use LLM routing, otherwise we will be using a keyword based routing. Okay, and optional, let's import optional from typing. Okay, so now supervisor agent will work, and then prompts we have added, and now it's time for the chat workflow. So in the chat workflow, if we go to chat workflow file, here wherever we are doing self.supervisor agent, in this one we need to pass LLM service, self.llm service, and we will pass here use LLM routing true. Okay, and now let's save it, and now let's check what is happening there. So let's go over here. And now let's say over here, hey, how are you? Let's send it. Now you will see it is summary agent started what. There is an error. Okay, let me do one thing. Let's restart. CD backend source activate. Okay, now UV call basically that command. So app main reload and the port. Okay, application startup completed. So chat API request using custom model. Summary agent started generating chat API request. So here chat API request received by flow route resolved handling parallel route. What? Why parallel route? Let's go to tracing. Let's close it. Let's see the latest trace. So chat workflow. So these kind of schema validations are, okay. So there is there is an error. But I have one question: why it is not awaiting? So okay, so on the chat workflow state dot route. Okay, so here it is now async function. Okay, so we need to await for it, and then it will resolve it. Okay, and now I guess it is restarted. Let's clear it. Hey, how are you? Now generating supervisor. This requested model not supported. Also, LLM API is throwing error like these are not supported or something is happening over there. Okay, so supervisor is using which model, by the way? LLM based routing, LLM prompts, generate, question answering. Maybe this question answering is not available, so I will use summarization one only. Okay, so oh, this is printed. So yeah, these are steps like later part, but our main goal is to see. Okay, so summarize. We are using DeepSeek, and let's see what it is routing. So we are asked to another user. What? How this can be possible? So LLM returned an error. Okay, line 87. Why? Okay, let's see why he returned a different route. That so these things, these things are hallucination. Even we are not providing him that, yeah, that function or method name is still supervisor decide route parallel. No, no, this is the output. Uh, what he has given. Mm, so for this, let's go to prompts. We need to do more better prompt engineering. So let's give it this. So we can explicitly, improve the prompt to say, give only one output. Okay. So this time we have changed the prompt, and now we can go to supervisor agent, and max tokens we can keep at 20, and temperature we can keep at 0.0. Now let's see what LLM responded. So we will log here the response. It is a short response, so we can log it without any issues. And if so, this thing we can remove. Okay, and we will see here for valid route, invalid route. We will do a small loop to check what is the response, and accordingly we will. So from here we will be having a valid route, otherwise we will be at the end by default the parallel route. Okay, so yeah, these are the things. Let's name it LLM. Let's observe this as well. Okay, and let's add calling mm, llm dot prompts dot routing decision. So let's see the prompt as well. Okay. Um. So yeah, I think this is it, and we can add one more over here in the supervisor agent. One more log after response. Okay, raw response length. So this is how basically we will see. Now let's clear. Let's reload. Hey, how are you? Okay, so we need to restart. There is some issue. Now let's see calling LLM for routing decision. Uh, LLM routing response received. But what we have received, is it not logged? This is not fair, bro. I can't see anything. No, if there is LLM routing decision is there, then we are good. Otherwise, our changes is not saved. So LLM routing decision is there, and in this preview, what? What the heck is this? So summarization will some keep on summarizing things. So, but I guess question answering well is not there. Metalama. Why you are not supported, bro? Okay, the name is this featherless AI. Okay, then I will go to env backend and then update over here. Okay, question answering. Okay, featherless AI. Now let's restart. Now let's go and load. Hey, how are you? Now chat API, chat recording and routing decision. Featherless AI. So let's see what featherless AI will respond. So after lots of research, I found that this Quen 2.57b instruct is available, and you can see over here we are using this model for question answering, and you can see 8 character is generated and response is basically greeting. Okay, so greeting sorry, so on the greeting one, what, so on the greetings you can see we are able to do this, and if I say find Langgraph docs, so now it will again go and it will go to handling search route. Okay, so search engine is started and search result for what, Elasticsearch. Explain Redis caching, so it will be, I guess, go to parallel now. 7 characters, handling summary agent. Yeah, so this is gone to the parallel. Okay, and so let me check data. Search for lang views. Let's see. So Elasticsearch has given this from the lang views. Okay, yeah, so this is correct. Our LLM based routing is working now correctly, and for fallback we have added keyword based routing. Okay, so we are good. We have implemented sorry, we have implemented this LLM based routing. Now one more bonus part is for you. I want a very more complex data, or something more important like PDF or anything. So I will go to Google and search for PDF implement. Let's say that you have multiple PDF, multiple CSV file. Okay, so you can just put in this data, and it once it is ingested, you can ask question about it. So for that, we will install a package. So go to requirement.txt, just add here pypdf2. Okay, let me close this, open new terminal, source bin dot you activate cd backend, activate. Now pip install -r requirements dot txt. So pdf1 will be installed. Okay, now let's clear it. And we need one more Python multipart. okay, for the file upload. So one more we need to add. Let's install. So this is also installed. Now in let's create a file PDFIngest. Okay, so we will go to app, data ingest, and let's create here PDFIngest.py. So now in the PDFIngest.py we will import whatever we need to import, basically py, PDF and PDF reader. Now we will create here a function to load all documents that we have on the data. Okay, so let's import. So here you can see this is a comment like used for extracting the data. Now we are importing PDF reader, the file path name, okay, and total pages, and we will be processing this PDF with this pages. And what we have to do for every pages, we will do enumeration with a start one, and we will extract the text, and that text will be appended into this dictionary, and once it is done we will return documents from here. Okay, so this is PDF ingest part, okay, that we are doing. And after ingesting it we will also load documents. So for that also let's create one more method. So load documents from PDF full content, okay, and this is load documents from PDF. So processing PDF as a single document. So here are the also same thing we are doing over here. Okay, now after this let's create one more file over here, file ingest.py, and in this file ingest.py what we will be doing, we will be basically detecting the file type. Okay, so for that you need to import this thing, load document from CSV, load documents from PDF, and we will detect it is a PDF or CSV. And after that we will load documents from the file. Let's create a function for this. So here it will be, you will be passing the file path, okay, and if it is a PDF then we will call the load documents from PDF. If it is CSV then this function will be getting called. So these are basic stuff, that's why I am doing right now copy, I mean, you know, like directly writing the code, otherwise it will be wasting time for you, so I don't want that. Now we will load documents from the directory. So for that we will create one more method, load documents from directory, in which you will be passing directory path, file types, or recursively we will check all the files. Okay, so if recursive then this pattern will be used, and rglob is recursively yield all existing file of any kind of matching the given relative pattern anywhere in the subtree. Okay, and if not recursive then we will be one by one iterating. So yeah, these are the documents and some of the documents, and from here we will be getting the result after all the patterns from CSV and path. So this is a file ingest, and after that file ingest we will be having a support for the file types. So we are just supporting two files type currently, PDF and CSV, so create a function for it. Okay, now in the ingest models we need to change something. So in the ingest models ingest models.py, we will be importing field and this typing from the this thing. And what we will do, we will create a file ingest response. Okay, so this is a file ingest response, then batch ingest response. Okay, so how much total is progressed. Then there will be a class for request of uh, ingestion. So this is the directory file type. So these are the parameters that you will be passing, and you can remove this. Now we will go to ingest router. Okay, so in the ingest router we will import os and pathlib from the path and the temp file. Okay, now we will import more things from the FastAPI over here. So let's import upload file as well. Okay, and we will import ingest app data.ingest, not just csv we will be importing, we will be importing lots of other things. Okay, so we are importing load documents from directory, load documents from file, and from the models we are importing ingest models, we are importing these other schemas as well. And now what we need to do, we need to create one router post. Okay, in which we will be having a function. So if we go to ingest.router, we can down the line over here ingest sample data, we can create load documents from csv. Okay, now over here we will create upload file. So upload file can be pdf or anything, and then we will be creating a temporary file. Okay, then we will upload it or load it. So these things we will be doing, and we will be indexing in our Elasticsearch, and after once it is done we will clean up the temporary file. So these are basically Python stuff, not related to AI or anything, but yeah, that's why I'm making it fast. Okay, you will easily understand, like Elasticsearch bulk index document. So all this response we are getting it, and the same we will create one more function for basically ingesting in the batch. So this will be the batch ingestion. Okay, so data will be ingested like this. So here you can see file summary, error, total index. So all the files whatever is there, that will be batched for indexing, and this one for putting content in the Elasticsearch. So once it is done, we will go to search service. In the search service we will add over here keyword, and that will be more like basically page number, total pages, and file name what we have added. Okay, this will be there. Now after this ingest files to Elasticsearch. So here we will be creating one more file in the script basically. So So I think a scripts folder is not needed because we are doing through APIs, we don't manually do it, so we can simply remove it. Now let's start a server. Okay, so it is started. Now let's go here, reload. Now ingest data. So indexed. So let me see where this API is getting called. Here, and if I go to ingest router, we have defined the sample data for CSV and this one for upload file for batch. So we will use this. We are not going for single. So here let's make it API v1 ingest batch. Okay. Now I think frontend has appeared. Ingest sample missing location message will required. This router import HTTP exception and depends. Now we will use here current users, depends current user, and then request will be there. Just request and just default. So by default the path is data. Okay. Now ingest docs into I think ingestion is completed. Okay. Bulk index, files, sales, PDF. Okay. Everything is done. But 200 then. Okay, so something has changed on the front end. Okay. I will update this. No, don't need to worry. Now if we ask for what is the in the sales PDF, if I see for hotel and 10 laundry daily total, something like that. It is daily totals for hotel and 10. Okay, so you can see we are getting the response, but this is the entire response. It should give me the exact. So let me see which search only. So search where is search for so search only keywords can be updated like this, and Now we need to go to LLM prompts and we need to update like question is this. So here the routing options can be changed. Okay. So we instead of um, routing decision we need to update. Okay, we will update routing decision with this prompt. Then we will update get all templates. So in this one we will add this routing decision as well. And okay, let's see what is happening after this. So let's ask what is the total sales. Okay, so yeah, this is why I mean good LLM is required. Okay, you can see the prompt and the answer are not correct. So in chat models we have added page number, file name. Okay, so that will be sent in the response. Then in a page search service, if we go to float, here we have added page number and file name. Okay, and in the search agent so whatever we are receiving is state dot search result or index item enumeration. We are appending the file path and the location parts. Okay, now in the chat workflow we go to chat workflow. Instead of combined answer over here, what we are doing earlier, we will be having method like. Now let's update. There are some changes in the router over here in the final answer. So final answer will be a summary output. Okay, let's reload it. Let's ingest again. So you can see now this is the response that we have added. The total daily total for hotel and is this source also they have given. So you can see this is the daily total 2 to 11:35 something. What is happening? Go. Yeah, 2 to 27 70. This is weekly total. Okay, yeah, so there are some indexing issue, but you can see we are getting the error. Sorry, we are getting the response. laundry for Sunday. Okay, so you can see we these things can be improved more and more. Okay, Redis caching. Oh shit. So my LLM is done. So you can see so far we have developed and ingesting data, and you can see in the tracing also. If I reload, you can see okay, this one is the we are expired. Okay, um which one then? Yeah, this one. So in this one, chat workflow will be started. Okay, LLM generate. So user question is what is language observability, and we retrieve these documents with okay, and this is the conversation history previous. Now this LLM generate is getting called with this all details what we have, and does not contain about language observability. Okay, and the summary agent will not put also the same thing, and search agent have done for Elasticsearch. And yeah, so this is how it is going on. If I say hi, I will say hi. Okay, so some models are working, some models are not working. When you make too much calls, then this happen. So this is so far what we are going to develop, okay, based on the PDF that we have ingested in the data AI tooling and sales PDF. You can answer and it will give you output whatever you want to ask. Okay, and if you want to open a new chat, you can just reload this window, and let's ask explain Redis caching. So so you can see we are getting what is Redis caching from the memory. Okay, and we can ask what is Langfuse observability as well. So yeah, sometimes it time out, so that's happen. Okay, no issues. So this is so far what we have developed. In the upcoming next video, we will be more working and improving this AI, like will implement stuffs like checkpoints, etc. So our main point is learning it, and you I hope you have learned and understood the concept. So that is what I want basically from you. And yeah, rest coding can be done using your Claude or anything AI editor, cursor, etc. You can do that, but you understood like basic workflow and how we are working with FastAPI and Langchain Langgraph. So yeah, that is it. If you like this video, please hit the like and subscribe button, and please comment if you are watching this video till now. In the next video, I think I'll be using same project or different project. Okay, and don't forget to give it a star on GitHub. Thanks for watching this video. We'll see you next time. Bye bye. Enjoy your day. Bye bye.